district, state, all over India, on the behalf of Mahatma Basweshwar Mahavidyalaya Latur, in collaboration with Indian Association Physics Teacher and jointly organized by the Department of Physics, Electronics and Computer Science. I warmly welcome to all this one-day international webinar on the quantum enigma, unveiling reality secrets. So we are highly grateful to our honorable patrons from Honorable Shri Adinath Sangve Sahib, President, Mahatma Education Society, Latur, Honorable Shri Madhavrao Patil, Vice President, Mahatma Basweshwar Education Society, Latur, Honorable Shri Madhavrao Patil Taklikar Sahib, Secretary, Mahatma Basweshwar Education Society, Latur, and Shri Sunil Midkari Sahib, Vice Secretary, Mahatma Basweshwar Education Society, Latur, and other directors of Mahatma Basweshwar Education Society, Latur, for their constant support and encouragement in organizing academic and research-oriented activities, and also grateful to Principal Dr. A.T. Shivali sir to give permission for such a webinar. So most welcome, sir. I respectfully request to our estimate Secretary of Society, Honorable Shri Madhavrao Patil Taklikar sir, to kindly accept the chairpersonship of today's program and grace the occasion. Also, I request Principal Dr. A.T. Shivali sir to chief guest of today's webinar program. I also request Dr. S.M. Dongarke sir to guest of today's program, and also request to Amit Pawar sir, guest of today's program, and I also welcome to today's organizer speaker, keynote speaker, national and international keynote speaker. I warmly welcome. Also, I respectfully request to Dr. S.M. Dongarke sir to welcome today's guest, Dr. A.T. Shivali sir, Principal, Mahatma Basweshwar College, Latur. I request Dr. Dongarke sir to welcome Principal A.T. Shivali sir. Thank you, sir. Also, I request Amit Pawar sir to welcome Dr. Dongarke sir. Thank you, sir. I also request Karan Singh More sir to welcome Dr. Amit Pawar sir. Karan Singh More sir. I request Karan Singh More sir to welcome Dr. Amit Pawar sir. I extend a floor welcome with words of respect and appreciation to the speakers of today's webinar and inaugural speaker of today's webinar, Dr. K.M. Jadhav sir, keynote speaker G.H. Jadhav sir, international keynote speaker Zaklina Lubej ma'am, and Antonija Barisic ma'am. Also welcome. And I also welcome to all participants, researchers, guides, students of all over India from different state and different district. Again, all respected professor, researcher, student, and participant who have joined us online from various districts of Maharashtra, all over India, as well as from other state. I extend a warm and heartfelt welcome to all of you this one-day international webinar.
जय हिंद.
सर अनम्यूट झालं बघा. सर अनम्यूट झालं. अनम्यूट झालं. पण बोलतील ना. तुम्ही सांगितलं का अनाउन्स केलं फोन करू का हो.
I respectfully invite Honorable Madhavrao Patil Taklikar sir to address us with few words and guide us. Honorable Madhavrao Patil Taklikar sir, Secretary, Mahatma Basweshwar Education Society Latur, to address us with a few words and guide us for today's international webinar. Maybe sir is unavailable. Thank you. So dear friends, today's academic webinar, more than 300 distinguished participants have registered from all over India as well as from various districts across the country. This is certainly a matter to great pride and motivation for all of us. In the today's international webinar, in-depth deliberation will be carried out of our four topics, great importance in the field of physics and modern electronics. So this topic are one is Albert Einstein photon theory and its role in modern electronics. Second one is quantum mechanical modeling of charge carrier in nanoscale devices. Third one is beyond classical, the strange rule of quantum physics. And last one is impact of quantum size effect of semiconductor devices scaling. So the successful organization of this webinar has been made possible through the kind permission, guidance, and support of the estimate office bear with Maharashtra Mahatma Basweshwar Education Society as well as the respective principal of the college. This has served as the key pillar behind the success and this academic invitation. On behalf of the organization committee, I express my sincere gratitude to all of them. Thank you. Now we proceed toward the inaugural session of today's webinar. It is matter of the great honor and privilege to invite our inaugural speaker, Dr. K.M. Jadhav sir, Emeritus Professor of Physics at M.G. University and former Senior Professor at BAMU University, to deliver the inaugural address. However, before the inaugural address of the key speaker, being its both the appropriate and instrumental to present detail, precise formal introduction of the speaker. Therefore, delivering an insightful introduction of the keynote speaker of today's keynote organization, keynote speaker. So I request Mr. Patole sir, may kindly request to introduce the key speaker, Dr. Patole sir.
Thank you, sir. Thank you very much. Good afternoon to all. I am here to introduce our inaugural speaker, and Here, it is my great honor and privilege to introduce our inaugural speaker, a distinguished academician, eminent researcher, and internationally recognized scientist, Dr. K.M. Jadhav, sir. He is currently serving as an Emeritus Professor of Physics and head of the department at MGM University, Chatrapati Sambhajinagar. He has also served with a distinction as a senior professor of physics at Dr. B.A.M. Mahavidyalaya University, Chatrapati Sambhajinagar. He brings with him over 3 decades of teaching as well as research experience with remarkable contributions across material science. His distinguished research includes more than 300 publications, 4 patents, 5 major research projects, and 7 books. His scholarly impact is reflected in more than 13,000 citations with a H index of 69. It is very excellent. Okay, and in recognition of his outstanding scientific contributions, Dr. K.M. Jadhav sir have been named among the top 2% scientists in world by Stanford University as well as AD Scientific Index for multiple consecutive years from 2021 to 2024. Ladies and gentlemen, we are truly honored to have such an eminent personality with us today to inaugurate this prestigious webinar. With great respect and pleasure, I invite Dr. K.M. Jadhav sir to kindly deliver his inaugural speech. Thank you very much. Please, sir.
Thank you for your nice introduction, and also thankful to the college authorities, Principal S.M. Dongarge sir, for giving me the opportunity to speak in inaugural session of this international webinar arranged on quantum technology.
सरांचा माईक म्यूट झाला. हा, ओके.
1 minute. As I said that this is the International Year of Quantum Science and Technology, which is going to be celebrated all over the country, not only the country, but all over the world. So in the inaugural session, I will just brush up the important things of the International Year of Quantum Science and Technology. I will introduce to the what is quantum science, quantum technology, how it is useful for and what are their applications. So the story of quantum technology was began 100 years ago. The pioneer work made by the Werner Heisenberg in the field of the quantum mechanics in the year 1925. He is the first person, or he is the first physicist to introduce the quantum mechanics to the world. He developed matrix mechanics in 1925 and received the Nobel Prize in Physics in the year 1932. What is matrix mechanism? It is just giving physical properties of the particles in a matrices form. We know the Heisenberg for his famous uncertainty principle in 1927. He highlights the limit of measurement of accuracy, especially significant for tiny particles like electrons, where classical phenomena breaks down. So this is the famous uncertainty principle. Delta x into delta p is equal to or greater than h cross upon 2 pi. It means that simultaneously measuring both the exact position and precise momentum of a particle is impossible. So we will not go into the details of this uncertainty principle, but how it is started, the quantum mechanics, just to give. So two things cannot be measured simultaneously. This is the simple word message given by Heisenberg. So to recognize his contribution in the physics, in the field of the quantum science, quantum mechanics, the United Nations has decided to celebrate the year 2000 2025 as an International Year of Quantum Science and Technology. Exactly after the 100 years completion, the UNO has decided to celebrate this year as the International Year of Quantum Science. Heisenberg, Max Born, Pascal Jordan in 1925 developed the matrix mechanics. It described the physical properties of matrices that evolve in time rather than wave function. So what is quantum technology? It is based on the behavior of atomic and subatomic particles such as electrons and protons. Quantum technology works on the principle of superposition and entanglement. These are the two important words in the field of the quantum science and technology, the superposition and the entanglement. In short, what is superposition? It's simply, in simple word, in classical computing bits can be in one of the two states, either 0 and 1. Whereas in quantum computers, quantum bits or qubits can be both states at the same time. This is the difference between the classical computers and quantum computers. This enables quantum system to represent and process a vast number of possible states simultaneously. Thus, the classical computers may require many years to solve one complicated problem, whereas the quantum computer will be able to solve the problem within a minute or a few minutes. Entanglement is another important quantity in the field of quantum technology. It is a phenomenon where two or more quantum particles become linked so that their states are dependent on each other irrespective of how far apart they are. The main aim of the celebrating the International Year of Quantum Science and Technology is to create the awareness amongst the common people all over the world about the quantum science and technology and their application. So awareness is very important. Secondly, to prevent the climate change, to investigate the new energy sources, to investigate the new medicines and the many energy sectors or sources using this quantum technology. At the same time, it is very important to create equal opportunity for quantum education to all the nations. So every nation should know what is quantum technology. What India is doing at the global level, like other nations, other countries, India has taken a lead in quantum technology. The government of India has established National Quantum Mission, NQM, and has made budgetary provision of rupees 8,000 crores for this National Quantum Mission. So under this National Quantum Mission, various funding is available to the researchers and the institute where we can work on the quantum computing and quantum material and devices. The aim of the mission is to promote the research in quantum science and technology, providing the funding for startups, etc. So at our state level, the government of Maharashtra, in collaboration with UNESCO, had decided to organize various events. The institute like either Pune, IIT Bombay are focusing on the quantum processes and safe communication. Now we'll see what are the applications of this quantum science and technology. The important is the cyber security to create the communication system without hacking and with faster rate. Nowadays, hacking is going very dangerously, and to avoid the hacking, so this will be helpful. Medicine manufacturing, by understanding and analyzing the complicated structure of molecules, new medicines can be developed very fastly. For weather forecasting, using quantum technology, better and accurate climate forecasting can be made possible. Further, for the natural disaster, it can be predicted too earlier. So using quantum technology, we have a lot of applications that should come into the realization. These are some of the application areas of the quantum science and technology. Quantum computing, it is multidisciplinary field that utilizes quantum mechanics to solve complex problems faster than classical computers. It works on the principle of 0 and 1. So in quantum computer, both positions can be available. Quantum communication, it uses the laws of quantum physics to protect the data and faster communication. Quantum materials, to explore the quantum materials with unique quantum properties. The material which show the quantum confinement like superconductors and topological insulators. To enhance the artificial intelligence, quantum mechanics learning algorithm can potentially enable more efficient and accurate training of AI models. So in short, what is the conclusion of the celebration of International Year of Quantum Science and Technology? The International Year of Quantum Science and Technology 2025 is not only the celebration of scientific discoveries, but it opens the doors of quantum technology to common man. This quantum technology has a strong potential to change the human life. It will impact in future on energy, medicine, security, communication, and other fields also. By accepting quantum technology, we are moving towards the Vikasit Bharat. So, all last year, that is 2025, and we are at the end of this year, and we entered in the 2026. During the whole 1 year, many institutes have arranged various programs, various webinars, various workshops to make awareness of the quantum science and technology. In view of that, the IAPT, that is the Indian Association of Physics Teacher, Sub-Regional Council, that is for Marathwada, established for the Marathwada region, has also taken initiation in this task or in this program. We have the RC08 has arranged many talks on quantum science and technology. So this is, I think it is the 6th talk. It was arranged by the Mahatma Basweshwar College, Latur, to make the awareness about the quantum science and to enter in the field of quantum technology, because the future is depend only on the quantum technology. The revolution can take place with the with the evolution of this quantum technology. So it is the duty of every teacher, student to enter in the field of quantum technology and to work in that direction, because our life will be more comfortable, more easier, and we will have a number of applications. So I am very much thankful to the organizers for giving me the opportunity for a few minutes to share my knowledge about the quantum technology. It is very difficult to explain the quantum science and technology, and that too in front of my guru, Dr. G.K. Bichile. It is very difficult to explain the thing, but I shortly introduce the students and teachers to what is the quantum science, quantum technology. So I think I'll stop here. Thanks for giving the opportunity to me. Thank you very much to one and all.
Thank you so much, sir, for your inspiring and thought-provoking inaugural address. You guide us something about quantum. We all know that beyond the technology, quantum science helps us understand how matter, energy, and light behave in the natural world, shaping our overall understanding of the reality. Thank you so much, sir. Now, I respectfully invite Honorable Madhavrao Patel Takrekar, sir, Secretary, Mahatma Basweshwar Education Society, address us with a few words and guide us. That's
Hello.
all, Afrika Sahib.
Uh, Good afternoon to all delegates attending the online webinar on this innovative topic of quantum theory, jointly organized by our reputed Mahatma Basweshwar College and AIPT. The well-reputed Mahatma Basweshwar Education Society, Latur, is the parent body of several educational institutions, including Mahatma Basweshwar Mahavidyalaya, Latur, which was established in 1970. Mahatma Basweshwar Mahavidyalaya impart quality education and to around 4,000 undergraduate and postgraduate students in arts, science, commerce, social work, computer science, with the aim beginning the intellectual awakening of the transformation in educational, economic, social, and culture field of Marathwada. It has a big campus with our multi-storied building, a playground, very well equipped laboratories and library, having a collection of our lack of books and journals. The motto of our college work is worship the Mahatma Basweshwar and well believe in the power of work. This institute was founded on principles of Lord Basweshwar in 1970. Initially, we started Deshikendra Vidyalaya to impact education to children from all concern of society. The member realized to importance and need to higher education to general healthly. Dynamic youth of Open Mahatma Basweshwar Mahavidyalaya in 1970 with arts, science faculties and commerce faculties was added in the 1971. Institute started faculty social work in the year of 1983. Mahatma Basweshwar Mahavidyalaya is one of the leading colleges of Marathwada region, Maharashtra state. It is a college with a difference as well. The silence features of our college are building quality, conscious among the students, teachers, and non-teaching staffs, innovative and creative approaching the education, interdisciplinary approach, commitment to rural sector, and down dropping selection of staff in made purely of the merit basis. The college has developed the necessary infrastructure of a hung dimension with the spacious classrooms, well-equipped laboratories, and separate hostel for the needy boys, ladies common room, tin room, audio and computer centers, and big playgrounds, library, building, 2 reading rooms, separate for building arts and commerce and science, MCVCM, social work and faculties. The college has produced a number of doctors, engineers, professional entrepreneurs, social workers, administrators, teachers, artists. Mahatma Basweshwar Mahavidyalaya is not only the leading college but also the college with difference because devotion and dedications hunting the efforts of the principals and teachers, motivations, management. Response of the college received the Best Examination Center Awards in 1997 to 1998 by the Swami Ramanand Tirth Marathwada University, Nanded. The topic of the international webinar is highly innovative. We must be decisions for participate the applicability in our daily lives as we celebrate the 100th anniversary of the foundation of development in quantum machines, we are remain the quantum science is no longer just theoretical dreams, but the rapidly transitioning in the commercial and technical reality. Today, we brings together leading science and researchers and students to be discuss how quantum physics has evolved from the fundamental inquiries into the practical applications, ranging from the quantum computing and quantum communications. We are honored to have two international resources persons among us today who will share insight to the fundamental aspects of the quantum theory as applications. We look forward to the enriching for sessions and interactive for discussions. At least I welcome to all I welcome to you all to enjoy this international peace today. I also offered my best wishes to all online participants to make this webinar a grand success. Thank you for very much and have a great day ahead. Thank you.
Thank you so much, sir,
Thank you. Thank you.
uh, for your few words, which inspiring us. Now we proceed to the international guest speaker session. The key speaker of this session is highly experienced, distinguished, and respected personality in the field of academic and research. Before the session, I request Dr. M.M. Bedkar sir to introduce today's international guest speaker.
Thank you, sir. A warm welcome, all of you, respected patrons of the Mahatma Basweshwar Society. Just we have blessed Secretary Antonija Madhavrao Patil, Principal of this college, Organizing Committee of this college, International Organizing Committee, National Organizing Committee, and Local Organizing Committee. And the eminent speakers we have invited here, Dr. K.M. Jadhav sir, Dr. G.S. Jadhav sir, Zaklina Lubej madam, and Antonija Barisic madam, who is invited as an international guest speaker. So Einstein is a part of respect of work and love of all. Irrespective of our faculties, if someone invited to speak on Albert Einstein, they definitely accept. And the same thing we have happened here. Organizing committee decided to invite the eminent speakers from abroad also, and both we have joined here, Antonija and the Zaklina B.A.M. madam. I welcome you, ma'am, on the behalf of Shri Mahatma Basweshwar Mahavidyalaya patrons and organizing committee. And just I give the introduction of both speakers in short because their work is very great. So Antonija Barisic is University of Applied Science at Velika, Croatia. Her education is in applied science and her work is leadership, workplace consultant, crisis management engineer, EFT practitioner, more than 200 clients, and supporting professionals to lead with clarity, transforming stress into the purpose of the, and her approach is practical. Her educational projects she have did supporting to the educational projects and the country head of the Mohonaji Youth Club, Croatia and Slovenia. So I welcome you, ma'am. At the same time, I respectfully invite and introduce Dr. Zaklina Angula, ma'am, who is Mahle at Constructor University from Germany, who is Doctor of Philosophy, PhD in Industrial and Organizational Psychology, People's and Organizer Development Expert. Her projects are physical tech predict inclusive education in Nigeria. Those projects are implemented in the inclusive education in Nigeria. She is volunteer, International Women Club, Brigadier, and multilingual. She knows so many languages, more than 6 languages. Her work is published. Both have published their research work, and their contributions are education, environment, health, human rights, and disaster humanity relief policy, poverty, allocation, science, and technology. I welcome both of the speakers, international speakers from this organizing committee, and I welcome one of them. First of all, Zaklina madam, then Antonija madam. You can deliver your speech. Thank you for the organizing committee.
Thank you so much for this wonderful introduction and for being part of this wonderful webinar today. It's always a pleasure to deliver these international speeches to such a wonderful audience. And I'm really happy to be here with you today. I will share my slides now, and I'm super excited about the session today. And hopefully you will also, you will find it interesting. I will not deliver on the topic of like other people, like other respected professors in the area of physics, but more on the topic of psychology, because that's where I'm an expert on. So here are my slides. Hopefully you can see them. My topic that I chose for today is thinking differently, and those that have already attended some webinar sessions know that I'm super excited about neurodiversity, about people who are thinking differently, and Albert Einstein is definitely one of them. So today we will be briefly exploring unique perspectives on Einstein's genius. We all know that he's very famous for all of his contributions to physics, but also to the area of psychology, where we're studying people with very unique IQ and very unique abilities. So that's why I've decided to take this perspective today. And yes, so today, what do we have in store? We will talk about Einstein's intellectual independence and the neurodiversity appreciation. A lot of people in the field of psychology have studied geniuses throughout the history of humankind, and based on how he presented himself, we think that he is neurodiverse, and I'll talk about this a little bit later. What does that mean? And what does that mean for you as distinguished professors in India? And what does that mean for the field, for education in general? I know in the introduction, somebody mentioned that quantum physics and this whole area of physics education should be available to all. And I completely agree. And who knows, maybe there is another Albert Einstein hiding there in amongst you or amongst your students. So you should be best prepared to support them. So this is what I will be talking about today. And a little bit about myself. So I do come from a field of psychology. I have a master's degree from Canada in psychology, focusing on, especially on attention hyperdeficit disorder, and as well as on autism. And I have a PhD in psychology, focusing specifically on how to make workplaces as well as education available to everybody, regardless of their abilities. I have worked as a consultant in Germany, China, Nigeria, Canada, Serbia, in this area. And I'm really super passionate about this. I am aware that the environment and the role that everybody plays in the education is huge for the future. And I want to just underline, if nothing else comes out from this session, is to understand that you play such a huge role by the way you teach and interact with your students in shaping the future of education in physics and broader in India. So you have a huge role to play in your students' lives. And I just wanted to say that before we get started. I will talk about psychological insights, and I will not be using any physics equations or anything like that because I am no expert in this area. I'm more interested in how great minds think and how they have contributed to science. I just also wanted to say that when looking back at how Einstein lived, he was marked as a great genius, but he was also struggling much at school. He couldn't find his ground, so to say, because of the very rigid ways of the way schooling was structured back in the day in Austria. So he wasn't necessarily marked as a super great student. That also being said, there is no real clinical data that says that he has been diagnosed with neurodiversity or ADHD or anything like that, because these terms did not exist back in the day. But there is a whole field of psychology that studies wonderful, great minds, and Einstein is definitely one of them. And it has been puzzling psychology for a very long time. How do these people think? How do they come about? How are they coming up with all of these wonderful theories? Is it nature? Is it nurture? Is it that they have inherited that from their parents? Or is it something in their environment? This is still a mystery, to be honest, but there are definitely indications that their minds do work differently. So they're not like, so to say, neurotypical people. Their minds do work differently. They do think differently. But that being said, because they are such geniuses and so wonderful in some areas, they struggle in some other areas. So what I want to say is that because Einstein was such a great genius and he had this hyper focus and was so interested in the way things work in nature and in the realm of physics, he was struggling with having friendships. He was struggling a lot at school because he was not interested in all the different topics and subjects there. He had trouble sitting for a long periods of time. He had troubles making friends. So he was marked, believe you me, as a problematic child. Can you imagine that Albert Einstein, one of the great founders of physics, has been marked as a poor student and couldn't complete his studies because he was having issues with a very rigid school system? So that's why I'm saying that the role that you as educators play in students' life is so crucial. Imagine that your student was Albert Einstein, and now imagine that you marked them poorly, and there he is, a great genius, a person that has contributed so much, not just to physics, but to humanity in general, and that you did not recognize such a talent. That's why it's very important to open your eyes to all of those geniuses and all of those people that may be acting differently. For example, people like Albert Einstein, he would go for days without eating. He would go for days without contact with other people. This is not just Albert Einstein. I also have to say that Nikola Tesla was the same way. He was not interested in so much in contacts with people. He was hyper-focused on what he was interested in, on topics that he was interested in. So not on the education necessarily as a whole and traditional as we see it. So all of these things that I just mentioned, hyper-focus, geniusness, trouble making friends, restlessness, all of these things are indicative of neurodiversity. And what is neurodiversity? It's just a different way of the mind operates and the mind works, and it shows in different. It shows differently in different people. I wanted to say here that he was a misunderstood genius, but the environment and people around him helped him flourish So thankfully, once he was out of school and out of this super rigid system, there were people on his path that recognized him as a genius. So this is what I want to say, that it just takes one person. It just takes one person to recognize people's potential. And I have to say that also people who are neurodiverse, so people who are hyper-focused on some things, but they're not interested in other things, definitely have issues at school. They might have behavioral issues, like throw temper tantrums, have issues making friends because they're not necessarily interested in people who don't have the same intense passion. So one person that played a huge role in Albert Einstein's life is his wife, who was supporting him. She was very understanding of his work and was there to support him and be this pillar, so to say, that helped him flourish and become the genius that he is. I also wanted to say briefly, what is, as I said, neurodiversity is just a different way our mind works. And there's strengths to this and there are challenges. I talked about this hyper-focus, about a lot of people with neurodiversity do have a higher IQ, but at the same time have higher tendencies of depression and anxiety. Why is this? Exactly because of the environment. If the environment sees you as different, as odd, as a black sheep, you don't fit in, you are then more likely to develop depression, to develop also anxiety, and then with such to be more inclined to abusing drugs, alcohol, or any other addictive behavior. So as such, I want to say this is something I tell educators all over the world. You play such a huge role because you can have this genius person in your classroom, and because you are not aware of it, and because you have such a rigid way of thinking what education means, you are punishing this person for their geniusness. And in fact, you're contributing then later to their depression and maybe being part of this environment that pushes them into some very dark places. So a huge, huge role that you play. And for, again, going back to the wonderful Albert Einstein, there were some other people who recognized his geniusness. So one of them is Max Tumley. So Max Tumley was his mentor. As I said, it takes only one person. He introduced him to advanced science and philosophy reading well beyond school level. And why does this matter? If you have a mentor, and you can be a mentor as an educator, who validates intensity and provides the right intellectual nutrients, this can be life-changing, especially when school feels like a poor fit. If you recognize somebody that's super passionate about your topic, support them, be there for them. Step out of your regular role as an educator, because you as an educator, you are nourishing the next generation of genius, and you are nourishing the future of science in your country. Another person that played a huge role in Albert Einstein's life was Marcel Grossman. That was his friend, who supported him both socially and academically. This is very important to have somebody, again, as I said, to support you and to understand you. And finally, the Swiss Patent Office job. Albert Einstein has such a hard time fitting in the world of work as well, because as he was very unique. And as such, he couldn't find a regular job. He would not be happy with a regular job, and his employers would not happy with him as well back in those days. I mean, even today, that's why we do so much education around what does it mean to have a neurodiverse employee at your place. There are currently a couple of companies, in fact, in the US who have specifically hired neurodiverse people to solve unique problems, to think out of the box, and they're very successful at the moment. So the Swiss Patent Office job provided him the income, the routine, and protected his thinking time. So why is this important? Many neurodivergent people do best with predictable structure plus autonomy. So they do need structure because routine and planning their time and organization is not the strongest feat usually for neurodiverse people. What does this mean? They could have many projects starting at the same time. They could be focusing on many different areas at the same time, start one project and never bring it to the end. So this is a struggle. If there is a nice organization, you can get so much out of people who are neurodiverse. But they also need autonomy. To be great, especially genius, does need autonomy. And this is something that we need to weave into the structure of education, providing just the right level of structure for students, regardless of their age, and autonomy. So there are some questions that I just wanted to briefly mention here. Did Einstein have autism or ADHD? These people who have autism or ADHD sometimes also struggle with eye contact. They may appear as weird or socially strange, might not be able to recognize people's emotions. This is something that I've also worked with children, how to recognize people's emotions and how to express their own. There, as I said, there is no definite answer to this, but based on all the available data that we have in the field of psychology, we do think that Albert Einstein did have both autism and ADHD, high functioning autism, which is also known as the Asperger's syndrome. And he was thinking a lot in pictures. So this is also something that I wanted to mention to you as wonderful and amazing educators, that when you are giving people instructions, your students, and you're talking a lot, that you need to also maybe provide some visuals, or you need to write this down, because with people who are neurodiverse, they're struggling. And I'm also neurodiverse myself. This is why I'm so passionate about it. And I'm here transparently sharing this. We are struggling with so much information and input that we are getting auditorily, because we are thinking in images. If you're sharing something with me, I'm imagining it in my head. What does that look like? So if I don't have time to process this, or if you're not clear about what you're saying and you're just sharing so much and it's not connected, it would be very hard for me to understand what is it that you want. So when you're presenting something, and this goes along for all students, applies to everybody, to be clear in bullet points and to also provide all of your instructions and everything that you share with students, not just orally, but that we can read it so we can go back to it and understand what you shared with us. So these are some practical tips for you, but the biggest message I wanted to share is just to be open to those students who may look different, who are struggling with or acting maybe in some weird way, to provide the structure and to just talk. Ask if there's something, going on that you don't understand, because as I said, maybe there is another Albert Einstein or Tesla hiding in your ranks and you are not aware of that, and you need to be open and educate yourself on what does this behavior present as and how you can best support these wonderful minds that can contribute to later on to physics and to humanity as such. So this is basically the end of my presentation. To provide more on this, on how to support neurodiverse students, I do have a lot of material on this. You're more than welcome to reach out to me via this email that I shared on the slide. And if you're not sure, if you want more education, I'm available for that as well on these topics. You're also welcome to take the time and study this on your free time. But I invite you all to take the time and think about your students and people that you are encountering in your life, and how you may have, maybe with your behavior and with your way of thinking, maybe you're not thinking the right way about some person. Maybe there's somebody there that you can support and help in a better way. So my ask to you is to take some time to reflect on this, to educate yourself, to come out of your comfort zones, to be educators, not in terms of just passing on knowledge, but supporting as mentors, because being a mentor is a great thing, not just an educator, but a mentor such as Aristoteles and Plato and all of these great philosophers. So with these words, I part from you today, and I thank you so much for this wonderful opportunity. I look forward to many more of these online international webinar series and talking more about wonderful people who have contributed so much to science and humanity. Thank you so much.
Thank you, Jaina, highlighting work of Albert Einstein and your message for the students and today's world. Thank you for joining here and delivering the best speech. Now I invite Antonija, ma'am, to deliver her speech. Thank you. She have introduced already. Thank you. Please.
Thank you very much for inviting me. I would really like to express...
You are muted, please.
Can you hear me now?
Yes, ma'am. Yes.
Okay. I would really like to express my deep gratitude for inviting me today. It is really an immense privilege that we gathered today and to reflect on monumental contributions of a figure whose very name is famous, Albert Einstein, and I really like to speak about him in this way. So before we start to speak about Albert Einstein, I will just like to introduce myself. My name is Antonija Barisic. I'm from Zagreb, from Croatia. Currently, I'm in the Netherlands. I'm working a lot with youth and with students, and I'm an advisor of the Mohanji Youth Club, also president of Mohanji Youth Club Croatia and Slovenia. And I'm academic. My academic background is crisis management. Also, I'm working as a leadership trainer at Success Empowered, and as an emotional freedom technique practitioner. So through my work, I've seen how deeply our thoughts, emotions, and inner energy actually shape our decisions, our resilience, and our ability actually to grow. So this is why I really feel strongly connected to the way that Albert Einstein viewed life, not only as a scientist, but as a human being. So Einstein was a great genius. And what truly made him extraordinary was not just only his intelligence. We only, when we speak about him, we think about him as a genius. But today we will speak more about Albert Einstein's point of view regarding emotions, energy, and compassion and love. Why I'm speaking about this today? Because I would really like to that all of us go with these thoughts that everything is, is possible if we, reflect on our emotions, if we reflect on our mind and our soul, of course. So Einstein knew that ideas began in mind and that they're powered by emotions. So curiosity, wonder, and passion were the forces behind his discoveries. So he understood that without emotional awareness and imagination, even the greatest intelligence remained limited. So it's important for all of us to remember we are all using artificial intelligence, machines and everything, and they're of course helping us. But before all this, there is like imagination. So somebody imagined that, and then how it's happened in the world. So I believe this perspective can help all of us today, especially students and young people. So when we understand how our inner world works, when we learn to balance our emotions and connect with our purpose, we unlock the energy that needs to dream and that actually creates. Albert Einstein knew this, and that's a message I want to leave us all today. So everything starts from the mind, but it grows through emotions and intention. So this is why today I want to share how actually Einstein's understanding of energy and emotion can still inspire us, it can guide us, and it can help all of us to move forward in our lives. So whatever we imagine in life, we can go through that and we can achieve that. Also, when we speak about Albert Einstein, it is, of course, tempting to begin with him as a genius. But he would not, he would disagree. And he would like to start with the point of emotions. So he believed that the most important thing in life, it's not science and intelligence, success or knowledge. For him, true foundations of human progress was curiosity, imagination, compassion, and moral responsibility. So he believed that wonder comes before understanding. So what does this mean? He often said that before any quotations and all these things, there must be curiosity. So be curious about yourself, about your life, about what do you want to achieve in life. Focus on your thoughts and go a little bit deeper into yourself. So Einstein has ability to ask always meaningful questions, and he said that it mattered more than the ability to quickly find answers. So another principle Einstein considered essential was imagination. So if we imagine the things, before, let's say, airplane comes, there was imagination about the airplane. So before a computer comes, there was imagination about computers. So everything actually starts with imagination. So without imagination, progress becomes mechanical and lifeless. So most importantly, that Einstein believed that human values must also guide with human knowledge. He warned that intelligence without empathy is actually dangerous, and that scientific advancement without moral growth could threaten civilization itself. So we all know that today a lot of things are happening, and that's why Einstein was always focusing on compassion, on humanity, on love, and this is what I would really like to put as intention today, that we all remember that if we are more into service to humanity, and if we are focusing on our thoughts and mind, that they're pure, that we have purpose in life, and to remember that we can achieve whatever we imagine. So that's all from me. If you have any questions regarding this, you can ask. But today I would really like all students and people who are here to remember how important we are, how we all have all these imagination in ourselves. So just focus during the day, like 2-3 minutes on your thoughts, on what do you want to achieve in your life, to what you want to imagine, and with this intention, go to the world, because whatever we imagine, we can create. Thank you very much.
Thank you, Antonija, with your valuable time and highlighting the Einstein's work and also the imagination of him in the field of physics and how the modern science is related to his work. Thank you for joining here. And as per your opinion, if anyone want to discuss, can discuss. Thank you for joining here, accepting our invitation.
Thank you.
So thank you from IAPT members and on behalf of Mahatma Basweshwar Education Society, Latur. Mahatma Basweshwar was also a very genius person to think about the socialism, freedom, and all other things. But similarly, the Einstein has given many issues in science. He discovered laser. He has given the theory of relativity. He has given the photoelectric effect, and also he has studied geniusly. And more than it, you have explained it to all of us. So thank you for that. Thank you.
Thank you, sir. Thank you, ma'am. So, in the point of view, medical science, every brain has a different operating system. The idea that brain difference are natural human variation and cognitive variations means people think and learn in the different but equal valid way. So Einstein said that the quantum enigma, unveiling reality secrets, is important in daily life because of principles of quantum physics form a foundation of many modern technologies we use every day. Device like that, smartphone, computer, and television work because of semiconductor and microchips developed using the quantum concept. So, all dear friends, it's way to going keynote speaker. So, before the keynote address being, it is both appropriate and essential to formally introduce the speaker. Therefore, for an insightful and scholarly introduce of the keynote speaker, now I respectfully invite Dr. Avinash Hedao sir. May we kindly request you to introduce the today's keynote speaker. So I call Dr. Hedao sir.
Thank you, Professor Dewar sir. Honorable patrons of Mahatma Basweshwar Education Society, honorable chief guest, respected principals, esteemed speakers, and my dear colleagues and students, good afternoon. I, Dr. Avinash Hedao, it gives me great pleasure and a deep sense of honor to introduce a scholar whose academic journey reflects dedication, discipline, and distinguished service to higher education. We are privileged to have with us Professor Dr. Ghanshyam H. Jadhav sir, an eminent physicist, senior educationist, and visionary academic administrator. Dr. G.H. Jadhav sir is presently serving as the principal of Shri Chatrapati Shivaji College, Umerga, District Dharashiv. With a remarkable teaching experience of over 35 years at both UG and PG levels, Dr. Jadhav sir has devoted his life to shaping generations of students since 1990. He is a university-recognized PG teacher and a PhD research supervisor with more than 22 years of research experience. His scholarly outputs includes 25 research papers published in reputed national and international journals. Adding a rare distinction to his academic profile, Dr. Jadhav sir is the author of internationally published book Light Quanta, Einstein's Big Mistake, 2023. His academic excellence has earned international recognition with research presentation at prestigious institutions such as Case Western Reserve University, Cleveland, and Notre Dame University, USA, under the Electrostatic Society of America. Today, in this one-day international webinar on the quantum enigma, unveiling reality secrets, we are indeed fortunate to have Professor Dr. G. Jadhav sir deliver the keynote address. We are confident that his profound knowledge, clarity of thought, and vast experience will greatly enrich this academic gathering. Once again, on behalf of organizing committee, I extend a hearty and respectful welcome to Professor G.H. Jadhav sir and request him to kindly address the gathering. Thank you. Thank you very much. Over to Dr. Jadhav, sir.
Thank you, sir. I am very thankful to the organizer committee, Basweshwar Education Society, patrons of principal, vice principal, all the participants from the abroad country and from the India too. Now the organizer has given me a very good opportunity to share my views. Already two participants shared their views about Albert Einstein. Now we are also going in that direction. Now I'll first share my slide. So now, friends, I am talking about the quantum enigma, unveiling reality secrets. K.M. Jadhav already declared that 2025 year as declared by the as a year of quantum science and technology. And at present, the world investing too much globally. I think maybe $55 billion or above to build quantum computers. K.M. Jadhav also said that our government of India in 2023 to 2024, up to the 30 to 31, to spend quantum mission money on the quantum mission maybe up to 8,000 crore rupees. So this is too much we are investing. At the present, we thought that quantum technology is a very good technology that we are using last 30 to 40 years when we discovered the solid state materials such as transistors and so on. From that technology purely based on the quantum science. But now at the same time, that is the quantum science, its a framework was completed in 1925. And in the last year, 100 years completed for that framework. That's why, declared to celebrate the year as a quantum science and technology. But meanwhile, in 100 years, people have different views about the quantum science. Now we know that Richard Feynman was an American scientist, which was very famous and giving good lecture about it. And you may read his lectures from books also. He said in 1964 that nobody understands quantum mechanics. And we always use this phrase when we teach the quantum science or quantum mechanics to the students. Later on, Nathaniel Mermin in 1989, he also said that shut up and calculate. Friends, what is meant by shut up and calculate? Actually, it is regarding to Copenhagen interpretation. Means prior to 1925, Bohr, Heisenberg, and Max Born, they were doing research or doing work in Copenhagen. And they were thinking about what is the quantum mechanics, what is he is saying. They are thinking there is no any draft of the Copenhagen interpretation, but they thought and just concluded some ideas. And the final output of that ideas is that shut up and calculate. Means don't ask what is happening there, only shut up and only calculate. What the calculation gives, that is happening you as well. So means the topic of this webinar is also good regarding that. Now, what is the condition at the present, friends? At the present, American theoretical physicist C.N. Carroll, you can see his videos. He is from Baltimore, USA, at I think Maryland University. He is a philosopher too and good physicist. He also says that quantum mechanics is grapes, as like such grapes, and physicists are foxes. The fox can't pick pick grapes. So he says the grapes are probably sour. So this is the position of the physicist here. That is, any physicist can't understand what is quantum science. Though we do not understand, but last near about 50 years, we are using the quantum science in technologies we are developing, because we know something, but we don't understand what is going at the atomic level exactly, because its a prediction is very different from the what we observe universe day to day in life. That's why it is difficult to understand what is going under the laptop or under the mobile. So this is the fact. But now what happened? Now we are going beyond that, and we are going to build the quantum computer. And Dr. K.M. Jadhav already said that the quantum computers are operating on the qubits. Qubits means in classical computers 0 and 1. These are the 2 bits which used by quantum classical computers. And qubits means these 2 bits can be considered as qubits, and they always exist in superposition state. So this superposition state can be handled by the quantum computer. So speed of the quantum computers will increase, capacity of this will also increase, and lengthy calculation can be instantly done. So these are the expectations from the quantum computer. That is why first America, not I think China, in the global investment, China is leading, then the latter is European Union, and then that of the USA. And private players like the IBM, Google, Microsoft, these are also investing. So people think that we do not understand quantum mechanics, and we are investing so much. What is the problem with the quantum mechanics? For that, we have to go historically, philosophically, how the development of the quantum mechanics was made step by step. Then we can come to some conclusion. And this is very difficult, because we are always follow some people, and we always follow what are the working at present, and we are thinking above that or beyond that. But what happened in history and why we are not understanding the quantum mechanics, for that we have to go in the history, because if the quantum mechanics is based on some flawed assumptions, at that time prediction of the quantum science will be also flawed, and which cannot be understood properly. That's why at present we are not able to understand the quantum mechanics. Now, first let us see what is the base of the quantum mechanics. We know that base of the quantum mechanics is the wave-particle duality. And it has also 2 parts, that is particle nature of waves. First proposed by Einstein in 1905 to explain the photoelectric effect, that is light behaves as photons or particles or light quantum. And in counterpart of that, wave nature of particles, that is electrons can behave as a wave, it was proposed by de Broglie in 1923 as a counterpart of the Einstein. Now let us first as the particle nature of wave proposed by Einstein. How Einstein entered in the quantum mechanics, it is very interesting to see, friends. Now I think one quote made by Einstein I want to share here. He is a Beso, and he is a best friend of Einstein. In 1951, that is at the end of life of Einstein, because Einstein died in 1955. And prior to 2 to 3 years, he said to the Beso, all these 50 years of conscious brooding have brought me no nearer to an answer to the question, what are light quanta? Nowadays, every Tom, Dick, and Harry thinks he knows it, but he is mistaken. Means Einstein saying that there might be no light quantum, means there may not be no any photons, but everyone is saying that he knows photons, he knows photons, he knows photons, but he is doing mistake. Means what was happening with Einstein, we have to see, friends, here. Actually, before or prior to this statement, in 50 years ago, Einstein invented or proposed the hypothesis of light quantum. But at the end of life, he was not accepting the light quantum. And today, on that light quantum is photons, we are doing work. And in 2022, for the photon entanglement, Nobel Prize is also given. Now we have to seriously think what is happening, what was happening with the Einstein, and how he entered in the quantum mechanics. Actually, Einstein had a girlfriend, and her name was Mary Milova, and whom he married on 6th January 1903. Prior to that, Einstein used write letters to her in the first 1 or 2 years of the 20th century. And from these letters, 3 are very important, which are we have to see regarding the Einstein's thinking about the photoelectric effect. From these 3 letters, one of them written on 4th April 1901, he says to Marie Mileva that I have doubts about Max Planck's work on radiation, the fundamental wave nature of light. Therefore, I am reading this article with mixed up feelings. So he was complaining about the Max Planck paper, which was published in 1900, that is end of that year. In the next letter, just written 7 days later, that is on 10th April 1900, he was still complaining about the Max Planck's paper. Now it is interesting why Einstein was complaining. Actually, what happened while deriving the black body radiation, Max Planck was used one hypothesis that in any hot body, if a molecular oscillator oscillates with a frequency nu, then the oscillator can give or take energy in the form of bundles of energy. That bundles will be integral multiple of h nu, means h nu, 2h nu, 3h nu, 4h nu. So first time Max Planck restricted the energy of oscillator on particular values, and that energy was represented in terms of frequency. Actually, what happened at that time? Oscillators means any hot body gives radiate energy in the form of light waves or electromagnetic waves. If it gives in the form of bundles of energy, means the light wave must consist bundles of energy, that is packets of energy. So Einstein called these are the quantum of, Max Planck called these as a quantum of energy. That's why Albert Einstein was complaining, because prior to that, light, it was established as a wave nature thoroughly, experimentally. So no one was expecting that it can have also particle nature. That is why Einstein was complaining. But one turning point happened after that. That is a letter written by 20th May of 1901, in which he mentioned that. Why he mentioned that? Because before writing the letter, means in the first or second week of May 1901, Einstein read another paper of Philipp Lenard. He was a German physicist. And after reading that paper, he again wrote a letter to the Mileva that, my dear kitten, that is, she was a girlfriend. That's why he mentioned as like a dear kitten. I have just read a wonderful paper by Lenard on the generation of cathode rays by ultraviolet light. Under the influence of this beautiful piece, I am filled with such happiness and joy that I absolutely must share with you. Actually, Philip Lenard Millet was a former professor. What was in that paper? So why Einstein became so happy? Because actually Philip Lenard was working on production of cathode rays. And he found that cathode means metal. He found that when a metal is irradiated by frequency or ultraviolet radiation, at that time, electrons are produced. It means a beam of electrons was produced, and that beam was called as cathode rays. So if frequency of that radiation was less than the ultraviolet, cathode rays were not produced. If frequency greater than that of the ultraviolet or up to the ultraviolet light, that cathode rays were produced, and that was found by Lenard, and he published his paper in 1901, and that paper read by Einstein. So Einstein becomes so happy. Why become so happy? Because Einstein now understands that this is a very crucial point in the life of the Einstein. He was just at 22 years at that time. Now he understood that Max Planck, when proposed the theory of black body radiation, he considered that a molecular oscillator can radiate energy in the form of bundles, that is the packets of energy, which is he called quantum of energy. Now Einstein thought that if these bundles of energy radiated in terms of light, light must contain quantum of energy. So he thinking that it can be independently proved theoretically that light can behave as a particle. So he was very eager to prove it, because that will be a revolutionary theory against the wave nature of light, and he was eager to prove it. That's why he's become very very happy to prove it theoretically. Now the question is that prior to 15 days ago, Einstein was complaining against Max Planck because Max Planck proposed that light, quantum nature or particle nature of the light, he was not accepting. But when he found the experimental result related to the Max Planck theory, now he turned from south to north pole and he accepted immediately that light can consist as a particle nature. It is a very surprising trend we have to think, because at that time Einstein was only 22 years, and at that age people becomes very excited in their thoughts. Because of that, Einstein turned from south to north pole and he concluded immediately that light can be as a particle, light can have particle nature. For that, he decided to write a paper or do the theoretical work for that paper. Actually, the paper he brought in 1905. It took 4 years. Why? I don't know. Actually, he concluded 1901 that light can be a particle nature, which was against his mind, but he accepted. But what he did to derive that paper? To derive that paper, he considered first as monochromatic radiation enclosed in a particular volume. When it transfers from one volume to another volume, he calculated change in entropy. And in the same volume, when n number of particles transfer from one volume to another volume, he calculated again change in entropy. He found that both equations were structurally symmetric, and from that he equated both equations. And finally, he found that epsilon is equal to r by n beta into nu, where r by n beta are constant. Epsilon is nothing but quantum of energy of that monochromatic radiation of frequency nu. These three constants further reduces to the product as h. So he finally found that epsilon is equal to h nu, which was proposed by Max Planck in black body radiation. But Max Planck was in only hypothesis. Now theoretically, Einstein derived this equation. That's why he get Nobel Prize in 1921. And using that equation, he explained the photoelectric effect, because we know that this is nothing but quantum of energy associated with a light of frequency nu. Then he said that any light having frequency nu will contain h nu quantum of energy or photon. They will travel with the light as a whole without dividing it. Then when it incident on a metal surface, one electron at the metal surface can absorb one photon at one time. It's a partial energy or total energy may be absorbed. From that, some part of energy will be converted into the work function to release from electron from the metal surface, and the remaining energy will be converted into kinetic energy of that electron. And this equation he brought, which thoroughly explains the photoelectric effect in all sides. That's why Einstein got Nobel Prize. Now let us think why Einstein had changed his mind from the wave nature of light to the particle nature of light. Is it true or not? Friends, I think that prior to deriving any theory, one has to assume some assumptions, some hypothesis he has to make. If these assumptions made prior to the theory are correct, then the theory should be accepted. If the assumptions prior to the theory are not correct, though the theory accepts or goes along the experimental data, it could not be accepted. For that purpose, we have to see, while deriving that paper, what Einstein have assumed. Now, Einstein already know that a light has a wave nature, and he assumed that this light can consist of a energy point as a photon or light quantum. Means this total light must be shrink to a point. We know that light is generated transition of electron in atom from higher energy to lower energy. At that time, a particular wave is created, and this wave goes in this direction. Whatever its frequency will depend upon the energy difference. This is current mechanics, quantum mechanics says. Now Einstein said that this light wave must shrink, or energy of that light must shrink to a particular point. That is, it is very difficult to accept. Why? Because we generally assume that the size of one electron is less than 10 to minus nanometer or 10 to minus 18 meter. And suppose we take a blue light having 500 nanometer wavelength, then in one wavelength, 10 to 7 electrons can be arranged in a row. And if we consider a total light having some crest and a trough emitted in this transition, then we will have, suppose, 1 lakh electrons arranged in one slot in a row, then 1 lakh such slots should have to be arranged in a light wave, and such a big light wave should collapse at a particular point. Do we accept it? Friends, if it happens before our eyes, then we will not be believe on our eyes, we will be stunned. If we don't see how this collapse happens, that is we don't see light, means it is not mean to accept all things. So this is very difficult to accept. Now second, what have assumed that energy, that this energy will concentrate or collapses to a particular point, but he didn't say anything about that energy. We know that generally we think that for the student initially when they are introduced in the 11th or 12th physics, we consider that kinetic energy and potential energy. We know that kinetic energy means a particle when moves in a particular direction, then we say that 1 by 2 mv square is the kinetic energy. We assume that means when it impact or collides on another body, that impact, how to understand, that's why we assume that kinetic energy means a body at rest or in motion, nothing is inserted in that body, means kinetic energy doesn't have any physical existence, but the body has a physical existence. Similarly, when we lift any body against the gravitational force, we consider that the work done is converted into gravitational force and total converted into potential energy, and total energy of that body is increased or raised up. It is nothing to say that body when below at particular level or above at particular level, body is the same, nothing is inserted in that body. So potential energy is conceptual thing to understand how amount of work done against any force. So kinetic energy conceptual thing, potential energy conceptual. Both energies do not have any physical existence. How the light quanta or photon have physical existence, it is very difficult to understand. Okay, let us accept that. Einstein said that light quanta comes into existence. Actually, we don't imagine what is that point. Is it divine power? If we think the photon as a divine power, then what will happen? It will do anything in the next. That is, we will not be able to predict what it will do next. So how can we make predictions along with the science? It is difficult. So actually people think that energy is simply as a divine power. It is totally wrong if we consider the scientific view. Now, okay, let us say Einstein said that the total wave is concentrated or shrink to a particular point and the energy point become produced. Now Einstein said that this energy point in the photoelectric effect gets absorbed by an electron. Now tell me how the electron absorbs that energy. Is there any mechanism associated with that electron to absorb it? Electron is single particle. It cannot have any mechanism to absorb energy or take energy. Another particle can collide on it. But energy cannot be absorbed and cannot be emitted. But Einstein said that the energy absorbed by the photon, does that electron eat the energy? It is very difficult. We only think that Einstein is great, he is very genius. No doubt he is very genius because at the age of 22 years, he thought much too much beyond at our age. So that's why he is genius. But one thing that photoelectric effect is instantaneous. Einstein had to go how the electromagnetic field in the photoelectric effect can apply forces on the electron at that instant and what is happening at that surface of the metal. But he didn't go, he went to the energy, total energy according to the classical electrodynamics, which could not predict. That's why he come to the practical nature of the wave. So Einstein said that electron absorbs energy, but we don't know. Let us say electron eat that photon, accept it. Now, conversion of that energy. Einstein said that this energy gets converted into kinetic energy. I ask a question, why the photon energy must be converted to kinetic energy? Is there any scientific reason? Friends, is there any scientific reason? Think about that. There is no any scientific reason why the photon energy is converted into kinetic energy of the electron. Is there any scientific reason? No, friends. Only we think that So here is a one person drinking the energy. That's why he is climbing the wall and going above. It is like just like the photoelectric effect explanation. We are accepting 120 years that explanation. Why? We are not able to think independently. Why? We are thinking that if it think in that way, if we think in that way, it becomes wrong. What will happen with my position and so on? This is very shameful. We should think independently. We should, what is happening? We have also brain. We can also think, not like the Einstein, but little maybe. But using that brain, we should think, everyone should think, okay, let the photon energy gets converted into kinetic energy. Now, in which direction the electron should go? Is there any reason? Can electron decide in which direction go? People say that the electron goes when random direction. Electron goes in random direction means that is a student in a class. If you give energy, it will go in a random. Student will decide in which direction he has to go because it has a mind. But electron does not have any mind in which direction he has to go. How will decide? Who will decide? This is also no one asked to Einstein. People think that when the electron goes in a random direction, those electrons when come perpendicular to the metal surface, we count for the photoelectric effect. That's very good. But they forgot that in 1923, Compton showed a Compton effect that when X-ray incident on loosely bound electrons to an atom, the electrons get scattered, and scattered X-rays have larger wavelength, means low energy according to our quantum mechanics. And he said that our expressed or proved the total effect using the conservation of energy and conservation of momentum. That is, and using that, he also concluded that X-ray were behaving as a billiard balls. Wow, very good. Okay. That is, at that time, he said that the X-ray were behaving as a light quantum or photon, and at that time, the energy and momentum of that photon will be absorbed by the electron in the Compton effect. Same rule is also applicable for the photoelectric effect. Now, this is a light wave, means it is photon going in this direction, means momentum of that photon is in a downward direction. What will happen? This, when the electron absorbs the total energy of the photon, means total photon it absorbs, then the photon should go in a first downward direction. Then what will happen next? We can't predict because it will go in deeper into the metal surface. But experimentally, we experimentally found that light is coming in the direction, photon coming are in the direction, but electrons are ejecting opposite direction. Why? Something there must be, friends, that is escaping or ejecting or dragging electron perpendicular to the metal surface. And who is dragging it? We yet don't know what is. Unfortunately, we are following. Friends, we have to think, not we have to compete anything. If mistakes are done in the history, because at that time people wrote what they have right. Now it is not necessary to always accept all there. We have to also think, if there are mistakes we found, it is our duty to correct these mistakes, because future generation will follow this, and for the future generation we have to keep correct whatever may be the theory. We have to precisely or correctly evaluate it in all sides, and then we have to put. If there is something that we cannot understand, keep the subject open. Do not close. Do not call the student, this is happening, this is right way, this is right way. Don't tell to the student. Keep the subject open. That this subject has to be kept open, but people didn't. They even at present, they are not thinking about that. Now the next is what is the role of electric charge or electric field of the electron? Actually, this is electromagnetic wave. Electron has a charge, but in photoelectric effect, there is no any role of electric charge or electric field of the electron. Is it possible? There must be a role, but we yet don't know what is that role. Now, another is that in that paper, if you read, actually, Einstein's paper about the, on heuristic point of view, concerning the production and transformation light, written in German in 1905 about the photoelectric effect, is not being read widely and not being taught to the student, mention it. But at the same time, Max blackbody radiation is widely taught to the student. Why? because Einstein's paper is simply a mathematical framework. Now, okay, in that paper, Einstein also mentioned that partial absorption of energy means Einstein said that the total energy h nu of the photon may not be absorbed by the electron. Some partial energy may be absorbed, he mentioned in that paper, but in the absorption spectra of atoms and molecules, it is not absorbed. We know that according to current quantum mechanism, when electron jumps from higher energy level to lower energy level, its energy difference gets converted into a photon having energy h f1, where this is the difference of energy. H is a Planck's constant, f1 is the electromagnetic radiation generated here. Now, when the electron has to go from this second level to third level, at that time he requires same amount of energy, otherwise he will not go here. Why? Einstein said that this electron can absorb partial energy, means if a photon having energy greater than that hf1, let us say hf2, this higher energy photon, its partial energy can be absorbed by the electron, it will go here at its n3 level, and remaining energy may be liberated in the form of another photon. If Einstein was correct, this should be found, but it is never found, friends. Why? And no one asking about that. Why we are following such? Now let us see that at that time, Einstein had a very great brain. At that time, he had to go for the force applying by the electromagnetic field on the electron in the photoelectric effect, because photoelectric effect is instantaneous. Never Einstein thought about it. Never any people thought about it. And 120 years, no one is thinking about it also. No one is thinking about this is also. Now, let us try, can we solve this problem? Now consider electromagnetic wave is falling on this, and it has a wavelength lambda here, and blue is the electric field, and this orange is the magnetic field. As electron at the metal surface initially at rest, we consider only electric field, and this progressively interact with an electron at the metal surface. And suppose one considers situation where electron at the metal surface is at this position. Now from that we understood that the electric field here is strong, electric field here is weak, and force of the electron here, should the electron should go in the straight direction or should follow a corridor path, because this asymmetric nature never discussed prior to this event. Now we elaborate here and we consider that electric field is asymmetric, forces in the direction, but we expect that the electron will not go in this direction, it should follow in this direction. But how the corridor path to be followed by that electron is impossible to understand, because this is never discussed prior to. Now to understand that corridor path of the electron, we have to consider the Newton's third law, which states that action is equal to equal and opposite reaction. Means when two bodies interact with each other, at that time there must be interaction between these two bodies, otherwise there will not be force. And using that, we consider a electric field in a light here and electron in the electric field. And suppose at the position of the electron is capital is the value of the electric field of the light here, and minus is the charge of the electron. According to classical electrodynamics, force on the electron is a product of the charge and the electric field as a position of the electron. We consider this as action. But in a reaction, that this electron should apply force on that electric field. No one has considered this. Why? I don't understand. Why we are going blindly? We have to consider this. When we consider the action equal to equal and opposite reaction, the third Newton's law, at that time we must come to this point. But never we came to this point. Why? That's why classical mechanics is not explained to proper things. And we are blaming classical mechanics, this cannot explain. Classical mechanics, this, that cannot explain. This is very foolish. Now we consider that the electric field applies force on the charge. Now this charge should apply force on the electric field, but there is no any such equation. What is, here is the electric field of the electron. This electric field of the electron, according to this equation, can apply force on the charge associated with that electric field. But the light here doesn't have, or any electromagnetic wave generated by electrical antenna doesn't have any charge associated with a wave traveling in space. But there must be mutual interaction. Option remains, friends, only one, that the electric field of the electron must apply force on the electric field of the light wave. Means thus electric field of the electron applies force on the electric field of the light wave. If it is the fact, then the electric field of the light wave must be applying force on the electric field of the electron, not on the charge. We have to understand already. We have to understand it. No one considering this. I don't know. That is, in the electric force, two independent electric fields interact with each other to produce electric force between them. There is no role of the electric charge in between these two electric field interactions. Means this equation is not sufficient. It must be generalized in the form of interaction between two electric fields. And this is not done at friends. That is, two independent electric fields can interact with each other or must interact with each other because they are of the same nature. That is field nature. And they will interact to produce either attraction or repulsion. Means force exerts in terms of the field interaction, not field charge interaction. This is totally wrong. Means we can't say there is a charge on the electron, but we can say the field is always associated with electron. Why the field is associated? We even can't say that this is because of the charge or charge is responsible to produce the field. Field is associated, that's final, but we don't know is there charge or not. What is happening? Then we say that the repulsion between electrons is because of the charge or electric field charge interaction. Actually, this is not. Actually, the two electric fields of the interaction electrons interact to repel from each other. Then question comes that Millikan's L-trap experiment done in 1909, he discovered the charge on the electron. If electron doesn't have charge, what he measured? He measured that the balancing force of the L-droplets charge by applying electric field against the gravity and found the balancing force value, and in reverse direction he calculated the imaginary value of the charge. He directly did not measure the charge, so we don't know charge. Now let us say what will happen in the photoelectric effect. In one light wave, we consider that suppose this is 1/2 lambda light wave in which this is electric field, and we divide this electric field into three sections: lower section, middle section, upper section. We know that in the middle section, electron should go here in the downward direction because higher field, lower electric field. So interaction must be higher and lower, because of that it should go here. In the middle region, the field is symmetric, electric field of the light wave, because of that electron should go in this direction, whatever their interaction. And in the upper region, electron should go in the upward region. That is when this is interacting in the electron at the metal. At that time, at that interaction, there will be no photoelectric effect. Electron will go deeper into the metal. At that position, electron will go parallel to the metal surface, but at that interaction, electron may be ejected from the metal surface, and that we have to understand, friends. And this is the classical mechanics. This is, in that way, people had to go, but I don't know how they haven't not gone. Because of that, Einstein said in his final year that there are no photons or light quanta. Something else must be there to produce the photoelectric effect. He was saying that look for that. And this is nothing but a look here. This is this we have to look here. Now consider here, that is, this is the portion of the light here at the metal surface, and electron here, what will happen with that electron? We already guessed that this electron should have followed a curved path. Means it can be ejected from the metal surface because of the electric field of the light. Now the light here has only one electric field, and the electric field is nothing but this is the maximum electric field is E0. It is gradually decreasing here. So whatever the force applied by the electric field, which is called effective electric force, and this is F, it will try to push the electron in this direction. So this F must be proportional to E0, that is electric field strength maximum, into the distance, how much this electric field spread over the region. We will come to the point this later on. Means the work done pushing the electron, work done is nothing but product of the distance and force. So this work done must be proportional to pushing the electron in this direction, proportional to E0. But there must be another force, because electron follow upward direction, there must be another force coming to existence. But yet we don't know. At least we assume that this force must be always perpendicular to the velocity of the electron. Means it can be magnetic force. And what is the value of that force? It is proportional to asymmetry of the electric field. Means it should be inversely proportional to lambda, are directly proportional to frequency, that is the net work done by the apparent force Fa and effective force F must be proportional to E0 into nu. If K is a proportionality constant, in lifting the electron in upward direction, work done combined by these two forces must be equal to K E0 into nu. This work is first converted into release the electron from the metal surface. Remaining will be as impact to the electron, means ejecting the electron, means it must be as a kinetic energy of the ejected electron. And this is the classical equation. In the classical equation, at least we are able to relate the kinetic energy to the frequency. People are saying that no relation between frequency and kinetic energy of the electron can be set up using classical. We have used it already here, classical. There is no any doubt why we are not going in this direction, what we are not thinking. Now let us say what was the Einstein equation. Actually, it is experimental equation, and this experimental equation doesn't include any E0. What is E0? E0 is the amplitude of the electric field wave. Actually, E0 is nothing but a light wave amplitude, and light wave is generated in atom by transition of one electron from higher energy to the lower energy. Means electron has a constant field, and we consider only by the jump. It is very difficult to only by a jump a particular electromagnetic wave can be produced. It is impossible. At that electron, at that atom, when the wave get produced, one of the electron in that atom must be oscillating with that frequency of the wave. And we have not tried yet what is happening there. In that direction, we are closer to the subject. Why we are closer to the subject? I don't know. So when one electron, when oscillates in an atom to produce an electromagnetic wave, the electron has a fixed value of the electric field associated with. So it may produce E0 fixed, because of that E0 may have fixed value. And product of K into E0 may be constant. It can be related to the H. Up to this point, H was only a universal constant, not related to any value of the universal, that is intrinsic value. But E0 electric field value, it is related to intrinsic value of the electric field of the electron. Means H may be related to intrinsic value of the electric field of the electron. So this may be constant. Now it is very difficult to accept this equation because we must provide an experimental proof for that equation. That is this equation experimental proof. Can we provide an experimental proof? Let us try. Let us try. Can we get an experimental proof? If we get experimental proof, that will be a revolutionary theory. Once again, after the Einstein, try friends for in your institute. Can we make any experimental proof or bring any experimental proof for this theoretical explanation? Now suppose an electromagnetic wave is generated. Actually, we know that there is no magnetic field, only asymmetry is producing the magnetic effect. Now let us consider this is electric field, or let us electromagnetic wave, and we consider only electric field of the electromagnetic wave generated by antenna, and it is propagating in this direction, and perpendicular or parallel to the electric field, CRTs are kept here. So we divide the electric field into subsections. Now we know that in the AC section, electrons must be here decelerated. Because of the deceleration, electron will go in a strong field of this electric field. So they will turn here while in the cathode ray tube. So they will turn here. This electron will turn here. When they are accelerated in this region C to E, they will push it in the weak field region. And at the point B, D, F, electric field is symmetric. Means there must be no any deflection of the CRT. Means this deflection should be proportional to, for constant amplitude, proportional to frequency, or inversely proportional to wavelength, that is proportional to asymmetry. Asymmetry is more when this is short, means inversely proportional to the wavelength. When this wavelength is short, deflection should be more according to our theory. That is, if this is because of the magnetic field, then if we increase frequency of any electromagnetic wave, keeping the amplitude constant, this CRT should give more and more deflection, and this is not found yet. Not found yet means we have not done experiment according to this, because classical electrodynamics does not support to this. Now, if we plot these deflections with using force is equal to Q into V cross B, that is magnetic force, at that time the corresponding magnetic field will have this value. Actually, this deflection is because of the asymmetry of the electric field. And if we consider this deflection is of the because of the magnetic field, and we trace using that classical equation, then we will find the magnetic field should have this waveform. Actually, when the electric field maximum, magnetic field 0. Electric field 0, magnetic field maximum, means there must be 90-degree phase difference. This is another clue we are getting here. It is also going against the classical electrodynamics. Now to check experimentally, we can design an experiment such like an electric antenna can be built, and from that electromagnetic wave can be generated of particular strength, and using the dimensions of the cathode ray tube, we can fix the frequency of the electromagnetic wave generated by antenna, and we can check. Now at initially, suppose we want to check whether the magnetic force increases with increasing frequency of the electromagnetic wave produced by electromagnetic antenna with keeping field strength constant. To keep field strength constant, we use CRT X tube, whose deflection is proportional to electric field strength. We increase the frequency of the electromagnetic wave, and we keep this perpendicular line as a constant, means frequency increasing, but this field strength is constant, means the value intensity is constant of the electromagnetic wave, only frequency we are increased. At that time, we check whether there is any change in the magnetic deflection of the CRT. For that, we use CRTY, which is perpendicular to the magnetic field lines. And if we find that increasing frequency, this length increases, it directly indicates that there is increase in the magnetic force with respect to increase in the frequency of the antenna. It can experimentally be observed, because at a very few or little sources at the end of 19th century or in the beginning of 20th century, physicists were made very brilliant experiment, and they also concluded few very good results from that, or assumptions or predictions also that, but some predictions they are ignored because of that quantum mechanics came into existence. So at present, this experiment may be possible. Any institute that can do this should do and find if there is a change in frequency or increase in frequency, the magnetic force increases or not. Second is the phase difference. If there is a phase difference according to the classical electrodynamics, no phase difference, and according to our theory, 90-degree phase difference. For that, again, we use a ramp generator. We apply to the two CRT, one is CRT X for the electric field strength deflection, another CRT Y for magnetic field deflection, and we form a waveform on that, and from that waveform we can easily conclude that there is phase difference in between these two waves. If it is not possible, we can directly give a signal given to the antenna to these two plates and form a Lissaj's pattern on the screen. If on one CRT there is a straight line and another CRT there is ellipse, surely there will be a phase difference, and this is against the classical electrodynamics. At that time, the classical electrodynamics will be in trouble. And first, if we do the experiment, this will first give impact against the existence of quantum mechanism, because using this experiment, we conclude that according to classical electrodynamics formal, this is zero phase difference, but our experiment says this is phase difference. But actually, the magnetic field is nothing but effect of the asymmetry, means magnetic field does not have any independent existence. It is only because of the asymmetry of the electric field, means in the universe there is only one electric field produced in the space, and this is considered as electric field. If then there will be no magnetic field, there will be no even gravitational field too. And this we have to understand, because whatever will be the ether or maybe may not be ether, the space will give to response to only one field, and field is nothing but pressure, and pressure will be one type. And once we consider that pressure as the electric field, then there will be no any magnetic field, there will be no any gravitational field too. Now let us see whether only the asymmetry is responsible to produce the magnetic effect, or there is another, because we already found that the electric force exists between the interaction between two electric fields. So to produce the magnetic force also, there must be interaction between two fields. What is there? Actually, when electrons are at rest, electric field is radial to that, and there is repulsion between those two electrons, which is because of the electric field, means radial component of the electric field producing the electric force which we usually find. But when these two electrons come into rotational, means spin motion, they produce a tangential component also. That is here circular tangential component, here circular tangential component. Now we consider there another force is existed, which is magnetic force. Actually, friends, electric field is radial component of the electric field of the electrons is producing the electric force, and tangential or parallel components of the electric field of the electron producing the magnetic force. Means there is interaction between tangential or circular components, and there is interaction between the radial components. Radial component responsible to produce electric field, and tangential component is responsible to produce the magnetic field or magnetic force field. So this we have to understand, and it can be understand from a magnetic field produced by straight current. How we have assumed a magnetic field of a straight current? It is very surprising. It is very tedious also, because current is a straight, and it's the effect. Magnetic field is the effect, and effect is circular. How a straight current? How circular effect can be produced, which has circular, which has a direction also? It is beyond our imagination. If we don't think, we only blindly follow what the people have said already. It is not the way to understand that. That is, this current, if is in the direction, it should produce its effect either parallel or anti-parallel to the current. And if we go thoroughly to the theory of this, or if we develop the theory, at that time we will find that this current produces parallel electric field to this. This electric field will not accelerate electrons. Parallel electric field component will produce magnetic effect, and radial electric field component will produce electric field effect. So if a current is proceeding in this direction, at that time electric field should be in this direction. When two parallel currents are, means two parallel electric fields are interacting and they are producing the magnetic effects. And this is the fact. If parallel current is producing parallel electric field, or straight current is producing parallel electric field, a coil should produce a circular electric field. And this coil should have two cones at the end of the coils. These are the two surface cones of the electric field having this direction related to the current. And value of the electric field at the surface of the cone must be maximum. If it is the electric field produced by current carrying coil, there is no magnetic field. Means what is the earth electric field? Earth electric field should have also like this, having two cones at the two poles of the south and north pole, having same direction of the electric field, but the cone will have surface on which electric field increases with respect to other areas. And this can be experimentally found by here formation of the aurora. In the earth of the aurora, the formation of aurora on the earth, aurora formation of the aurora is in the form of circle, indicating that at the surface of the cone, aurora activities are more. On the Saturn, there also the aurora is in the form of a circle ring in the form. If we consider this aurora is because of the magnetic field, at that time, the strength of the magnetic field is a maximum at its center of the pole. Means the aurora should be formed as like such. Center is maximum and decreasing the aurora intensity away from that. But this is not found. This is found, indicating that aurora, formation of aurora is responsible by the two surface cones of the electric fields. So from this, we conclude that actually light consists of only electric field. It has only wave nature. No photons are there. It can explain the photoelectric effect. For this, we have to go only deeper. Means if there is no particle nature of light, means half portion of the wave particle dialectic comes to the end here. So if there are no photons, means there are no entanglement of the photons. If no entanglement of the photons, means there will be no any communication system that can be developed using this photon. Now currently $55 billion they are invested by the country and companies also. This we are to think what we are doing. That is, if nothing is observed, get away from that, then what will happen? Slowly that money will go in the drain. And with that, our efforts too, and with that, coming generation will what will say about us? Think about that. Now another is the particle, wave nature of the particle we have to see. For that, friends, we have to go the atomic structure. That is from the beginning of the 20th century. Now one student from our college, that is CS college, asked a madam that sometimes a student asked, sir, if all the electrons in atoms are moving in orbits or behaving as waves, how a solid material can be formed, how a student can be formed, how a teacher can be formed, no one can explain it. Now, what happened with the atomic structure. Actually, in 1897, or a sheet of a structure of a spherical sheet of a positive charge, and in which electrons must be embedded, because he found that electrons are in the atoms. So he proposed a plum pudding model here as like such. But what happened with that? Actually, how this plum pudding model emits light waves cannot be explained. Because of that, people were thinking it is not. Though he found one particle from the atomic structure, electron, means atom was now divisible, but yet do not give any detailed information of the atom. For that purpose, Rutherford came into action, and he decided to see what are the anomalies in the Rutherford Johnson J. Thomson's atomic model, and he designed one experiment with his colleagues Hans Geiger and Ernst Marcedek, such that he used a thin gold file. Why he used a gold? Because of using the hammer, they can make thin layer of the thin file of the gold. That is why they used the gold. And on the gold, the alpha particles were bombarded on the file. File was very thin in the nanometer size. And they found that out of 2000 alpha particles, 1 or 2 are deflected or came back. All were passing directly through the file. And because of that result, Rutherford was so surprised. He said that the atom is totally empty. There is a vacuum, there is nothing. But some particles, means out of 2000, 1 or 2 alpha particles getting reflected back, indicating that something must be concentrated at the center of the whole atom. And he called this as a nucleus. Total positive charge of the nucleus atom is concentrated at near about all mass is also concentrated, and remaining electrons are distributed in the empty space. And using that experiment, he also concluded that what is the size of the nucleus with respect to that of the atom. He said that if we elaborate or expand the atom up to like a cathedral or a church, at that time nucleus would be simply a fly at the center of that the church or that of the cathedral. So this was the assumption made by, or prediction made by, or conclusion made by Rutherford in 1911. But later one thing happened, friends. In 1936, means after 25 years of his result declared, he said that it was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. He was saying regarding the incident or striking of, that is the alpha particle of the nucleus. He said that nucleus is a tissue paper and alpha particle as a cell, 15-inch cell, that is cell of a tank, incident on that nucleus. He said that nucleus was strong at its position. He was not losing its position, and the alpha particles were deflected. So fine. But it's what this result was predicting, what indications that this was giving, he totally ignored, because of in 1936 another theory came for the atomic structure, which was a quantum atomic theory. Because of that, this statement lose his significance. What we say that up to that time much water had flown through the or under the bridge. Because of that, this was very important significance, but they have not considered. Now, friends, we have to think that the alpha particle striking on the nucleus. Nucleus is just suspended in the atom. Atoms are suspended in the files. Means there is no any fixing material in the atom. Atom is totally empty space. Electrons are very, very tiny particles. They may be spread in that. But when alpha particles strike on that, electron do not lose his position, does not lose his position. Why? Who is keeping that nucleus with its position? No one thought about that. So, without thinking that, he concluded that Rutherford model, that he said that according to planetary motion, because electrons should fall directly into the nucleus, he said that according to the planetary motion, the electrons may be circulating in the circular orbits in which the centripetal force and centripetal force must be centrifugal and centripetal force must be balanced, and this planetary motion he brought there. Now the question is that we know that our student will teach that we are firmly gliding on our surface of our ground. That is, there is a strong repulsive force between the atoms at our feet and atoms of the surface of the earth. And there is a particular distance between that is we are floating. So this floating is means there is static force between our feet and the surface. And this static force must be because of the electron. We consider these electrons are revolving. How this can produce a static force means this is actually totally wrong. Now at present we consider electrons behaving as well. This will not explain how this. Another thing with Rutherford atomic model was that if electron revolve in a circular orbit, electron has its own electric field. Because of that, ripples will be produced. Using that ripples, the electromagnetic waves will be produced here, and this wave will be propagate away from the atom. Because of that, electron will lose its kinetic energy. It goes slowly down spiraling. It should collide with the nucleus. No one will save from colliding in the nucleus. So these were the problem with the Rutherford atomic model. Also, it cannot explain the spectra. And at that time, that is at 1897 or 1889, Rydberg formula was invented according to the experimental observation for the hydrogen atom, and this can explain the. It is empirical formula. It can explain the hydrogen atomic spectra. So this spectra or formula cannot be explained using the Rutherford. And at that time, Niels Bohr joined the Rutherford to investigate or to whatever thing flaws in the Rutherford atomic model. Now he first understood this formula, Bohr. Then he understood this spectrum. And then came he with that if there is a difference between two values, he assumed that the electron must be energy difference between two values. That is, electron should have fixed two values, and when it jumps from one value to another value, the radiated energy can be related to the emitted spectra. So he considered that the hydrogen atom consists of stable atomic orbits, or stationary atomic orbits in which electron cannot radiate energy. But when it jumps from higher to lower energy, it radiates, or when it absorbs energy, it can jump from lower to higher. But in between these stationary orbits, there will be no any allowed energy orbits for that of the electrons. And using that concept, he brought the Bohr's atomic model of the hydrogen atom we know all. Now, one thing is that he first assumed that when revolving in stationary orbit means in that orbit, integral multiple of angular momentum of the electron must be integral multiple of h by 2 pi. And these are stationary orbits he calculated, and he also calculated the frequency radiated. But one thing we have to see that though this goes with this formula or can explain the hydrogen spectrum, but thing is that he said in hydrogen atom there can be stationary orbits. We know that electron has its own electric field, and with that electric field he revolves. In any orbit it will also has electric field, and with that electric field if revolves, then ripples will be produced, and because of that they will propagate in the form of electromagnetic waves. Because of that, the energy of the electron or kinetic energy should reduce, and finally it should collapse into the nucleus. So no one can save. So this stationary orbit is never possible. Secondly, he said that when only by jump electromagnetic wave is produced. Is it possible? We know that to produce electromagnetic waves having particular crest and troughs, it must oscillate with that frequency. But Bohr assumed that only there is a jump because of it matches with this data and this experimental result. Because he assumed that, and we also accepted slowly. But we know that in electromagnetic wave generated by electric antenna, the current or electron must oscillate with that frequency. And in atom, when electron jumps from higher to lower energy, electromagnetic waves is created. This has a high frequency, it has a low frequency. When we increase the frequency of the current, frequency can be increased. And when we reduce this energy difference, frequency can be reduced. So in both directions, we will come to a point where cut point. Above that cut point, electron is to be jumped to produce the electromagnetic wave. And below the cut point, electron has to oscillate. And at the cut point, we don't know. Is it possible? Both are electromagnetic waves, but generation of the electromagnetic waves, the way is different. This is never possible because it does not support by inverse. Otherwise, we cannot predict what is happening next. Means this is actually we are doing. This we are expecting. If we are doing means it is fact. Means here also electron should oscillate, but we don't know why. So electron, so this should not be fact and this should be fact. Another in helium atom, there are two electrons. We know that if their net orbital magnetic moment is 0 means they must circulate in the same orbit in opposite direction. At circulating or completing one circulation, at that time they will 2 times close to each other, and there is a repulsion. Because of that, they will not follow the same orbit. And because of that, there is a they cannot have the net orbital magnetic moment 0. Means it is also indicating that electrons are not revolving. So all these things, electrons are not revolving, are saying from Rutherford to Bohr, but people are always accepting that electrons are revolving up to 1925, means 15 years later to also from 1911 to 1925. So why they were considered? Because they don't know how the electrons are balanced. Because at that time they know only 2 forces. One is attractive force, another is repulsive force. But electron has a more larger distance than that of the attractive force distance. Because of that, nucleus can suck these electrons instantly, and because of that, atom cannot remain stable. That's why they were unable to think there must be another force. And that force, they were not able to understand additional repulsive force. If they were found additional repulsive force, at that time, they found that electrons can balance at a particular distance. That is electric repulsive force, additional repulsive force, and the attractive force. And atom should have such type of nature, but they couldn't find. And after they found in 1925 that the Stern-Gerlach experiment, they found that they did in 1922. And after the explanation of Stern-Gerlach experiment given by Uhlenbeck and Samuel Goldsmith, in which he suggested that the electron has a spin motion. And this spin motion is responsible to stable the electrons without revolving or without behaving as a wave. And this fact we could not understand in the last 100 years. I don't know why. Because now presently we are believing on the quantum science. And because of that, this electron spin motion we consider intrinsic property as an angular intrinsic property of the electron. That's why we ignored it, and it is found in 1927. If this was found prior to the 1911, at that time we may thought that what the spin can have role in stabilizing the electrons in the atom. We know that this electron is spin motion, it acts as a tiny magnet. If these 2 electrons in opposite direction, their magnetic moment will be as like such n pole here, n pole here. It can have opposite n pole close to each other, means there must be repulsive. So there will be 2 forces now when they are spinning on the same axis with opposite direction. One is electric repulsive force because of the radial component, another is magnetic repulsive force because of the tangential component. And we also consider an effective magnetic field of this is 0 because it has his direction, this has this direction, total magnetic field is 0, but net repulsive force is increased. And if we consider or put a positive charge here, and the positive charge attract this, positive charge attract this attraction, and this electric repulsive and magnetic repulsive force get balanced, system can be balanced, stable, and this happens in the helium atom. Actually, helium atom is as like such. These 2 electrons are in opposite spin motion. They have 2 repulsive forces. One is electric repulsive force, another magnetic repulsive force. This attractive force, both are balanced at that time. the electron can be stable, and this can be proper structure of the helium atom. There is no any electron revolving or electron is necessary, not electron is in spin motion also. Further, there are two spin directions related to the nucleus. In this case, magnetic moment is inward, magnetic moment is inward, and in this case, magnetic moment is opposite. We can call here a spin down, we can call it as a spin up. Means in the helium atom, there are two electrons, they will be either in spin down, either in the spin up. And this can be considered as a first cell, as according to usual quantum mechanics is 1s2 cell. Now let us say how the helium atom can be formed. Actually, at the present, we don't know how the helium atom can be formed. Actually, we know that in core of the stars, atoms are formed. And suppose in the core of stars, two proton and two neutron combine together to form a nucleus. What will happen? They will attract two electrons. Actually, electron has repulsion. They must be away from each other. So two electrons will get simultaneously dragged toward the positive charge, means nucleus of the helium atom. What will happen? These two electrons will come close and close. At that time, the electric repulsion between these two will increase as they come close to the nucleus. But to reduce the electric repulsion, because they has electric field, it has also electric field. To reduce the repulsion, which is electric repulsion, they will be triggered in opposite spin motion. When they are triggered in opposite spin motion, their radial electric field reduces, means attraction reduces, electric repulsion reduces. But tangential component will produce another force, which we consider magnetic force. That is when electron comes close to this nucleus, to reduce their electric repulsion, they come into spin motion, and this spin motion continuously increases. A time will reach, a position will reach. At that time, the magnetic force produced between these two will be so high, that is the net repulsive force, electric plus magnetic force will be greater than that is the attractive force. At that time, they will go away from the nucleus. Again, what will happen? The spin will reduce. Because the reduction spin, they will again attracted toward the positive charge. So finally, with oscillation, they will stable at a particular distance where the net repulsive force, one is the electric, another is the magnetic, is exactly equal to the attractive force. At that time, this helium atom is formed. If electrons are not triggered in spin motion, atom will not be formed, and we will be never in the conference 2. This is the crucial condition in the formation of atom. And first atom is nothing but the helium atom is formed. Again, this electron can oscillate in this direction also. Now there are three forces to balance this electron. One is the attractive force, another is the electric repulsive force, another is the magnetic repulsive force. If we able to calculate these three forces, then we can easily calculate the distance at which the electron is balanced. And also we calculate what are the forces, means a force constant we will calculate, and using the force constant, what is the simple harmonic motion of that can be calculated, and we can calculate the frequency of the electron oscillating here, and that frequency will be natural frequency of the electron. Both electrons will oscillate with the same frequency. So this atom will radiate electromagnetic wave with that natural frequency only. Now, actually, the electron do have intrinsic spin. We will later see in next time when we will again come to close, because time is now very much going, or time is less now here. Now, what is happening in the helium atom? Now we know that two electrons are balanced at particular distance because of the force. Now this electron can oscillate here, this electron can oscillate here. Both will come simultaneously close and both go away from that. So they will oscillate with particular frequency, which is called a natural frequency. And this is nothing but quantum nature of the atom, yet we don't know. And this is the quantum frequency of the atom. This we have nothing to jump from here or here, nothing to behave as a wave. This electron is particle, this electron is particle with field. They can oscillate, produce electromagnetic wave in circular ring form, and which we will have particular frequency. But we know that helium atom produces different electromagnetic waves, that is specific different electromagnetic waves with specific frequency, indicating that if it produces F1 frequency, F2 frequency, F3 frequency, indicating that these two electrons can balance at different distances from the nucleus, producing different electromagnetic waves. So we have to understand where the electrons can balance and why only these 3 points or more points can balance, and why only they produce such frequency. Actually, these forces will decide at what frequency the electron should be oscillating, and this will be the natural frequency of oscillations of the electron. And from that, we can easily understand how the helium atom can produce different types of frequency. And this we have to understand. This is the quantum nature, not a electron behaving as a wave, not electron circulating in electron motion. Now, how higher atoms can be?
If you want to take some water or
so after that, I'm very close.
Okay. So you have to take sufficient time because we want to understand. Okay.
That's very fine. Okay, then I will go slow by because I am in a hurry. Time is I thinking over.
There is no time bound for you, sir.
Water molecule, carbon dioxide molecule, HCl molecule, and so on, step by step. Only after 2 atoms we will go there. So now the next atom, how it is formed, we have to see here. And this is the beryllium, lithium, I think beryllium atom. Now here there are 3 electrons. Actually, these are the 2 electrons from the helium atom. We know that. If suppose in the core of the star, one proton, 1 neutron gets added in the nucleus of the helium atom, and to balance the charge, another electron will be dragged. Now where it will stay the electron? The electron will stay in that plane. Either here, in that plane, it will stay. What will happen? These 2 electrons will already produce electric field. This electric field is combined electric field because of their spin. And this electric field has circular component also. This circular component of the electric field will bring this electron into spin motion. Now, the directional spin motion will be as like such. What is the distance of this? Distance of this will be greater than the distance of this electron, distance of this electron. These 2 distances are equal in opposite side. But that electron will stay away from the region or the net effective electric field of these 2 electrons. So, third electron will never come to the level of the first 2 electrons. That is why this we can consider as the first cell of the atom in which only 2 electrons will be here. No third electron can enter because every time a neutron proton gets added, they will have again more bonding, strong bonding. Because of that, the 2 electron will not allow any electron to enter in that level. Because of that, in the first level, that is, there will be only 2 electrons. We found this as a 1s2 cell, which is actually a subcell, only 1 cell in that first cell. And third electron will be here, and this will be opposite spin to that. And this will be balanced by the electric field of this electron and electric field of this electron. And this will be in spin motion. There are 2 possible spin configuration. Because of that, this atom will have, these are the 2 possible configuration. Now next is the beryllium. From the lithium, if another neutron proton get added in that, these are the 3 from the lithium. 4th electron if you get added to this lithium atom, because of the neutron proton get added in that of the nucleus, another electron will be dragged in the star of the core of the star. So this will automatically get balanced in opposite direction because of the net repulsion. And it will be at equal distance, and they will be then this in formation. Now we can consider this is the formation of the second cell. In the second cell, we found 2 electrons. In the first cell, we found 2 electrons. The second cell, distance of the electrons from the second cell is more or larger than the distance of the electrons from the first 2 cells. But one thing happens, yet I do not understand how. The second cell, now sphere of the second cell is increased. Now sphere of the second or area of the first cell was very small. Because of that, only 2 electrons are accommodated. But this area is increased because of number of electrons can be accommodated more. Because of that, there is a chance to include more electrons in the second cell, and this we can consider directly as a neon atom. In the neon atom, we know that there are 10 electrons, means 2 electrons in 1s2 cell that are already gone. Again, 2 electrons from the 2s2 cell, they are also gone, means 4 electrons are inside that. Now remaining 6 electrons out of this. That is this is the second cell, but it is subcell, and this subcell has an area more than that the second subcell 2s2. And distance is also more than the 2s2. Why? I don't understand. actually when we calculate the forces, how the electrons get balanced, at that time we can easily understand how the electrons are balanced. But they are formed properly pair. This electron opposite spin, this electron opposite spin, this electron opposite spin means net magnetic moment is balanced. Internal pairs are also balanced because of the neon atom is totally balanced, and this is second shell having two subshell, and in that only 2p6 subshell we have shown these electrons are balanced. One is along this line, another is this line pair, and third is perpendicular to that. Both first two must be here. So this is again a neutral atom, which is a stable atom. Now when another neutron proton gets added, at that time the third shell will have to form. That is, first two cells up to the neon are completed here. So it is very difficult to understand, but we have to go here. Now let us consider formation of molecules. It is very easy, this model, to understand how the molecules are formed. We know that in chlorine 17 electrons are there. So 17 electrons means 2 electrons will first cell, that is 1s2, 2 electrons from the second subshell 2s2, and 6 electrons from 2p6 as like from that of the neon. Now after the neon formation, this chlorine atom is formed. In chlorine atom, there are again remaining 7 electrons. 2 electrons will form again the third subshell 3s2. This is not shown here, but remaining 5 electrons are shown here. These remaining 5 electrons, they will always try to form pairs, because any atom or molecule had to maintain neutral electric charge and neutral magnetic moment. At that time it can be stable. If atom is not able to alone neutral magnetic moment, at that time it will form a molecule. So chlorine has 1 electron less to become a stable. Because of that, it forms a molecule, and for that purpose she takes sharing with the hydrogen atom. We know that hydrogen atom, there is a proton and 1 electron. So E17 electron of the chlorine is unpaired. Now to become zero magnetic moment of this, so if it has its spin in the direction, another it requires electron having spin opposite direction, and it can get chlorine from the hydrogen atom. If in the neighboring region of the chlorine there is a hydrogen atom, so this will pair, hydrogen atom will align here. So proton of the hydrogen atom must be away from that chlorine atom, because proton and this neutron will have repulsion, positive charge, and this electron will balance here. Already 4 electrons are formed 2 pairs, so 6 electrons are formed 3 pairs here. So this net magnetic moment of this chlorine becomes a 0. Now this hydrogen atom will be always here. It will not revolve here in this direction. It will not revolve in this direction. It will be always stable if we are able to take photograph of that chlorine atom. If advanced technology becomes, at that time I have confidence that we will find exactly where the electrons are located in the chlorine atom. Exactly, we can locate, and we can say that this will be according to the spin atomic model. This atomic model can be considered as a spin. This is the formation of pairs. This is the hydrogen atom. Remaining electrons are of the chlorine. Now consider another simple molecule, which is H2O. Now there are 3 atoms. One is oxygen, another is hydrogen. This is very important, because when we consider that electrons are revolving orbit, these 2 hydrogen atoms cannot be stable. And we know that there is a particular distance between them, indicating that they are fixed positions, they have fixed position. But we don't know why they have fixed positions. They have fixed position because of that they are not revolving only, they are in spin motion electrons in atoms as well as molecules. In oxygen, there are 8 electrons. As we usually we know that there is internal one formation of the 1s2 cell is formed, which is not shown. The formation of the pair will be there inside. Now the second shell will be again 6 electrons. 2 will form here, again 1 pair. This is not shown. But 4 electrons will be in the second subshell 2p6. And these are the 4 electrons, 1, 2, 3, 4 are shown of the oxygen. Now to complete the this cell, or to become neutral for magnetic moment, there must be 6 electrons in that. So how it is possible? That is, these electrons can form 1 pair, and remaining 2 electrons should form pair with another atom, electrons of the another atom. This is possible from the hydrogen here. Hydrogen atom has one electron. This hydrogen atom has one electron. If one electron from the oxygen pairs with hydrogen electron here, and another last electron E8 pairs with there, at that time we will have one pair in this direction, perpendicular one here horizontally, and this is a perpendicular to the plane of this paper, that is perpendicular to both. That is, there are three pairs are formed, and there will be fixed distance between these, because these electrons are not going here and there at normal temperature, and their formation of the molecule will be as like such. These are the outermost electrons are in a spin motion. This should be a picture of H2O, and we know that the angle between these two hydrogen atoms is near about or more than 100. That why it is more 100 or more than, because there is repulsion between proton, and this angle is fixed, means the electron must be fixed, means our electron must be fixed, and we yet don't know 125 years. We don't know, not 125 years. We are working on the atomic theory from the Kanad, 200 to 500 before the BC. Kanad was a Rishi from the Indian culture, who was working with the thinking about the atom. Up to 2000 or more than 2000 years, just we don't know what is atom, what are the molecules. Friends, we have to think once again upon this. Now consider another complicated carbon dioxide molecule. It is very interesting. Now we know that carbon dioxide molecule, there is one carbon and two oxygen. Oxygen has 8 electrons. So from 8 electrons, 2 will form first cell, 1s2, one pair, it is not shown. But in second shell consists again of 6 electrons. 2 will form another second subshell, 2s2, it is not also shown. And 4 electrons remain in 2p6. Actually, it requires 6 electrons, but only oxygen has 4 electrons. So 2 electrons will be required to balance the pair or the net magnetic moment to be 0. Another oxygen atom is also here. But what happens here? If there is a carbon atom, now carbon atom has 6 electrons, 2 will form an internal pair, that is 1s2. It is not shown. Now 2 electrons should form a 2s2 pair. Suppose this is 2s2 pair. And 2 electrons to form, 2 electrons will remain in 2p6. To complete its core, it requires another 4 electrons, which is not possible because only it has 2 electrons already in 2s2 cell. So 4 electrons, how it can be balanced? So this carbon atom cannot take electrons from the other atoms and to complete his cell. Because of that, this 2s2 cell will break and 4 electrons will be now free. And from that, 2 electrons will balance with oxygen. 2 electrons will balance this oxygen. These are the 4 electrons from the carbon, and these are the 4 electrons from that of the oxygen, 4 electrons from the oxygen, and this will be a molecule along a straight line. So what is here's a picture of the spin? Picture of the spin as like such. First pair of the oxygen, it is already formed, and 2 pair are formed with carbon electrons. Here 2 pair formed with the carbon electrons, 1 pair of the oxygen electrons. So this should be a picture of the carbon dioxide. So actually, we must find this. 125 years we didn't find this. This means what are we doing? I think it is very difficult. Means very in other way we are going here because of the only quantum mechanics. Now we see that why quantum mechanics arrived, because instead of finding this how electrons are stable because of their spin motion, we consider spin motion as intrinsic property, which is actually not. If electron spin is intrinsic property, the old CRT TVs could not work, friends. The old CRT TVs electrons were deflected by a magnetic field. If the electrons were behaving as a tin magnets, they will not be focused or they will not be scanned on the screen, and maybe picture cannot be produced. So that's why we are considering this as intrinsic spin. This is not intrinsic spin. This is because to balance the electrons atoms, spin is acquired by when the electrons dispatched from the atom, it will lose its spin motion. It will be free without any spin motion. Only to reduce the repulsion between the electrons, spin is acquired And if this has not happened spin, then we will not be here. Spin is triggered in the atom to balance the electrons. Now let us see. In Stern-Gerlach experiment, Goldsmith and Uhlenbeck considered that this result is because of the spin motion of the electron. That's okay. What happened, friend? In the Stern-Gerlach experiment, they did in 1922, that is after the First World War. They were trying to find the result in the First World War, but they had to go to duty in the World War first. They left their institute, their lab, and they went to the work for their country in the World War first. And later they came, and then later Gerlach did the experiment, and they found the splitting of the beam of the silver. What is it? They first consider as a oven here. Silver beam, silver is kept here. By hitting, the beam is produced. The beam is passed through inhomogeneous magnetic field, and they were expecting that this should produce such a type of exposure on the screen. Why? Because we know that there are 47 electrons in the silver, and only one electron is a valence electron in outermost orbit. And up to 1925, people were considering electrons are revolving in orbits, not a spin motion. Spin motion they found in the 1925. That is in 1922, they considered that the orbital magnetic motion. If electron in the last orbit is moving as like, it should act as a magnetic bar whose center of the magnetic pole is the nucleus. If it is moving in opposite direction, it will act as a magnetic bar, yes, up, and down, whose center of the pole is a nucleus. And if such type of atoms are passed through the inhomogeneous magnetic field, what will happen? If this atom passes, means N, it will be repelled, and it will go and it will strike here, produce the impact lower. If this atom passes through S, and here the N, means it will be attracted, it will go up, down, up, and it will strike here, produce the impact here. But if the angular, this spin motion, this orbital motion is perpendicular to as like such, at that time magnetic bar will be oriented. At that time, neither N, neither S will be attracted here or it attracted here. It will go straight and strike here. So for all possible orientation, such type of exposure was expected by Stern and Gerlach. But what happened? They found such type of exposure. At that time, they concluded that this orbital angular momentum also has a space quantization, which is a very crazy idea at that time. But what happened in the 1925, while doing theoretical work, Uhlenbeck and Uhlenbeck and Samuel Goldsmith, they concluded that the result which we found Stern-Gerlach was not due to because of this, but due to because of this. But actually they don't know electrons is here or here. They only consider it because of the spin motion of the electron. But now we know that at a present, the last electron, 47th electron, must be last outermost electron of the silver atom. And maybe here, or where maybe. But it is outermost electron. And all 46 electrons must be balanced, must be paired. Their net magnetic moment must be equal to 0. Only one electron must be outside attached to the silver atom. And this must be either in spin in this direction or spin in this direction. If the electron is in this spin direction, it will act as a tiny bar magnet with N pole outside the atom and S pole inside the atom. If it is revolving in this direction, at that time, it will also act as a tiny magnet where S is outside the atom, N is inside the atom. Now, such atom, it passes through the Stern-Gerlach experiment or inhomogeneous magnetic field. What happens? This N is outside the atom. What will happen? The N will get repelled, and because of that, this atom will turn here in downward direction. That is, N will come here, and that means N will attract toward the S. So while going in this direction, the atom will turn here slowly, and it will go here, and it will strike at the lower position here. When this electron, this atom goes through this inhomogeneous magnetic field, then S is away from the nucleus, means out of the atom. So directly S will be attracted here, it will go upward direction, strike here. Now suppose the position of the tiny magnet or electron is here. That is, N is here and S is here. And this atom is passing through that. What will happen? as S is inside and N is outside, this N will be get repelled here. Because of that, the N pole here will turn in this direction. That is, it will acquire as downward direction. So N will here, S is inside the atom. S will be inside the atom, N will be here, and it will slowly turn while passing through, and it will come and it will strike. And suppose this atom passes, that is here S, N at this position. At that time, what will happen? This N will be slowly attracted toward the N. Because of that, this S will pull it here and it will go in upward direction. That is, in this situation, there are only two chances. Either the atom has to strike here or either the atom has to strike here. That is, such type of exposure must got. And they got by Stern in 1922, but they couldn't understand. They consider only this also has a space quantization according to pressure of quantum mechanics, but this was not. Actually, this is because of the spin atomic model. But people do not understand as like such. They are again believing that the Smith and Uhlenbeck experiment. Now, actually, what happens in atom? Can atom emit any electromagnetic wave? No, friend. Suppose we elaborate or expand an atom and we hammer and we consider only three pairs here. One pair here, another pair here, and third pair here is. One pair close to nucleus, second pair just away from the nucleus, and third pair is away from both of these. What will happen when the first pair is close to the nucleus? The balancing forces will be strong. Because of that, the force constant will be strong, and because of that, natural frequency of the oscillation must be high. And when we hammer on such an atom, they will oscillate with their own natural frequency, not because of the atom. Hammer, or maybe because of the influence of the temperature, they will oscillate with this frequency, higher frequency. At the same time, these two electrons will oscillate, but with lower frequency because they are bounced away. And another pair will again oscillate with again a lower frequency because they are balanced far away from the nucleus. Since balancing forces must be weak, because of that, the force constant must be weak or low value. Because of that, their natural frequency of oscillations must be low. So this is happening while considering the black body radiation formula or deriving black body radiation formula. This situation has to consider, and then we can see how the catastrophe, ultraviolet catastrophe cannot be produced. Because only when we hammer an atom, only outermost electrons can oscillate, innermost electron cannot be oscillate. That's why ultraviolet light cannot be produced. People are always thinking that why atoms are not able to produce ultraviolet light, that is ultraviolet catastrophe. Even sun at a very, very high temperature cannot produce ultraviolet light. Why? Because the inner electrons are not easily oscillate. They are very strongly bound to the nucleus. This is very difficult. Either we have to insert one electron on that, at that time it can oscillate. Otherwise, only by hammering or only by temperature, they will not oscillate. Because of that, ultraviolet catastrophe cannot be produced. So actually, this is the fact. Now we consider X-ray production principle. Oh my God, this is very interesting explanation which we provide to the student. We think that, suppose, what happens in electron gun produces high velocity electrons and they enter to the atom. While going here, they will decelerate. They will stop here. And this, while decelerating will stop here means the kinetic energy from this to this point reduces to zero. Means this kinetic energy gets converted to X-ray. It is very difficult to understand. So why? Suppose because of the deceleration or because of the kinetic energy becomes zero, so this kinetic energy gets converted. So all the electrons may not have the same kinetic energy, but X-ray has the same frequency. Means kinetic energy must be same, which cannot produced by the any electron gun. So how X-ray of particular frequency can be produced? Never possible, never possible. Actually, what happens? All electrons are stable with their spin motion. When a highly accelerated electron goes inside an atom and goes up to or manages up to inner cell, at that time in an inner cell electron, on an electron, it can strike. When it strikes, the electron oscillates with its own natural frequency. This electron will go away from the atom again.
with losing its energy, but it will oscillate with its own frequency. Because of that, X-ray is produced with a fixed frequency because it has a fixed frequency of oscillation, which is a natural frequency, which depend upon how a distance it is balanced from that. Actually, this is happening in the production of the X-rays, but we are thinking in a different way. Also, it can happen, friends. That is when electron going in the direction. Suppose it strikes first here, then it strikes here, it strikes here, it strikes here, and goes in this direction. At that time, all the 4 electrons will oscillate their natural frequencies. That is, it is not X-ray, it lower electromagnetic wave. It may be X-ray, it may X-ray, it again low frequency electromagnetic wave. So 4 electromagnetic waves can be generated while trajectory of this electron. So we cannot predict exactly this X-ray will produce or the other will produce. It will depend upon the target, how the atom will allow to enter the electrons and so on. So this is a path of different study. And I think if we go along the spin atomic model, then we can easily understand. Another thing is that, friends, we consider that absorption spectra of atom. It is very difficult to understand absorption of a photon. Because at the present we also using the quantum mechanics that electron when jumps from E2 to E1, the difference of energy is converted into an electromagnetic wave or a photon of frequency F. Product is HF is equal to energy difference. Now we know that if this HF is given to the electron here, then at that time this electron will go back to the E2. Only this HF, this photon. I don't understand how the electron decides or knows or recognize incoming photon is of that value which he required. It is very difficult. Is there any brain associated with the electron? Is there any brain associated with atom? No brain with that electron. Electron is simple particle. How it can decide that incoming photon which is he required, other photon he is not required. Also we know that if HF2 is greater than this HF, then also this electron will not go because it is not absorbed. This wave goes here directly away from the atom. If the incoming photon have low value energy, at that it will not be absorbed. It will go away. If Einstein was right, partially energy can be absorbed. That is sufficient amount of energy can be absorbed from the higher energy photons, and it can go here. Remaining energy can be produced here. This wave must also be absorbed here. But we found only this frequency get absorbed, not other lower or higher frequency not absorbed. Why? Because actually what we are predicting, this is very flawed prediction. This is not happening. We know that according to spin atomic model, electrons, where they balanced, they have their natural frequency of oscillations. Suppose in an atom, electron is balanced here and natural frequency of F. So it will produce the F frequency electromagnetic waves. Now, if the atom is at ground state, means electron at rest at this here. Electron is rest. And incoming there is a wave. And the wave, suppose, fortunately has the same frequency as that of the natural frequency of the electron. What will happen? This incoming wave, its electric field will interact with the electric field of the electron. The electron will get oscillated because of the electric field. And what will happen? The frequency of this wave is the same as the natural frequency of the electron. So ultimately electron will get tuned or resonance with that wave. And what will happen? If the electric field of the incoming wave is upward direction, electron will go downward direction. That is, wave produced by electron will be 180-degree phase difference. So certainly electron is oscillation, electron will also produce a wave. Incoming wave and wave produced by electron, if there is a 180-degree phase difference, at that time there will be no any wave coming out. So total wave gets absorbed, and this is happening because of that. Why this particular frequency get absorbed? Why this frequency must be natural frequency of oscillations of the electron. Suppose the incoming wave has a different frequency than that. What will happen? This electron will not oscillate with that frequency. It will, if it oscillates, then it will oscillate with the natural frequency, and the wave produced by this and incoming wave will not cancel out each other. So the incoming wave will go in this direction, and we will find out. Means this wave will not be absorbed. Actually, friend, this is happening. This is happening in the atoms, in the absorption. But yet we don't know what we are doing in the last 125 years. It is very terrible because we are blindly following physics. This is not. So let us come to what happens with quantum mechanics within 15 minutes, then we close. What happened? Because people didn't understand how the electrons are balanced. They're always thinking what is happening, what is the atomic structure, what is the atomic structure. And what happened in 1905, Einstein, here is Einstein. Einstein given the hypothesis of light quantum is light is behaving as a particle. And instantly in D. Broglie was doing work in his PhD. In 1923, he gave a hypothesis as a counterpart of the light wave theory of the particle theory of the light of the Einstein, means against the Einstein. And he said that electron can behave as a particle, and the wave associated with the electron is equal to h by p. P is the momentum. Actually, if we go details with the De Broglie paper, at that time we will found that his assumption was very, very flawed. He considered that electron has an internal clock. The internal clock will have internal frequency. That frequency will produce a particular wave. That wave will guide the electron. So pilot wave, guiding wave, and internal clock, all this something very terribly, very flawed he assumed. But only thing accepted by the people is h by p. Lambda is equal to h by p. So this was the De Broglie hypothesis. But what happened later? Later, Max Born. Actually, Max Born was a close friend of Bohr. Where is the Bohr? I think Bohr is here. Here is the Bohr. And this Max Planck is a very close friend of the Bohr. And Werner Heisenberg was a very close. Max Born, Werner Heisenberg, and Bohr were before 1925, 2 years were in the Copenhagen. And they were thinking about if electron is behaving as a wave, where is the electron? Because the wave is spreading over space. Then Max Born came. He said that if psi is the wave function denoting the wave, representing the electron wave, then calculate mod psi square. And what is the value of mod psi square at position? This will be the probability finding of the position, electrons probability. Then we know that this principle was given by Max Born in 1926 because they were not able to explain where is the electron. Actually, electron can behave as a wave, can behave as a particle according to quantum mechanism. If we observe and we found that there is a particle, electron is a particle, where is the wave? Then wave must collapse to the particular point. Why the electron has a wave and that has to collapse? It is very difficult to accept, but people were accepting because no alternative solution. So that was a Max Born who was supported the Bohr. Then later came Werner Heisenberg in 1927. If electron is behaving as a wave, then wave properties must be implemented on that of the electron. Means the uncertainty principle delta x into delta p must be greater than or equal to that h by 2 pi or h cross. So that uncertainty principle in energy, time, and position momentum he brought. And the threes, one, and Bohr came together. They formed a structure of the physics up to 1925, and pressurely they implemented the quantum mechanics on the community. I say that directly on the community because there are so things were happened in the history of the physics. I will explain later. What happened after 1925? Later, Schrödinger also came in that. And he said that if electron is behaving as a wave, what should be equation of its motion as like force is equal to mass into acceleration in classical mechanics. So Schrödinger brought another equation. We know that Schrödinger equation. Actually, Schrödinger equation was not supporting the quantum mechanics. He only put he derived the Schrödinger equation. But later he was not satisfied with the quantum mechanics too. Only totally distracted from the quantum mechanics was the Bohr. And they came all together in 1927. Fifth Solvay conference, it is very fifth Solvay conference. Always physics people think about debates between Bohr and Einstein. What happened in that? In 1927, in the Brussels of Belgium, that fifth Solvay conference was completed. And at that time, if we count, there are 29 people who were participants. Out of that, friends, out of that, 17 were got Nobel Prize before conference or later, after conference. 17 means how brain of that world got together at the Solvay conference 1927. At that time, Einstein took a confirm opposition to the quantum mechanics. He said that suppose probability of finding the particle means if I first observe the particle, means because electron is not a wave, not a particle, it is in the superposition state. When we observe, at that time the electron wave will collapse into a position. At that time there will be electron. So Einstein said that if we observe, then there will be electron. If we do not observe, then there is not electron. Means electron will be fuzzy state. How it is possible? Then he said that I think it is 1945 to 1955. He was working in the Princeton, means that in USA, Institute of Advanced Study in the USA, Princeton. He was working, and his colleague was Abraham Pius. And to the Abraham Pius, he said that if I am not looking at the sky, isn't there moon? मीन्स मैं अगर स्काई पे नहीं देख रहा हूँ इसका मतलब चांद वहां पे नहीं होगा क्या? वो बहुत ऐसा डिस्ट्रैक्टेड था आइंस्टाइन, उन्होंने ऐसा कहा था. लेकिन उस वक्त एट दैट टाइम नो वन इज इन पोजीशन टू take care of Einstein's statement, because at that time Einstein's position in the quantum mechanics was not as such, because Bohr was opposing. Second is what happened at that. Einstein also said that is God does not play dice with, means probabilistic nature. We know that while the Max Born brought the principle of the mod psi square is a probability of finding the particle, means either particle here 50%, here 30%, here 20%, overall 100%, means particle is distributed throughout that region of the wave function. But Einstein said that the particle, when we observe, it will be either at 30% position or 50% or 20%. But when we observe, Einstein said that God does not play dice with that. Means he is playing dice where will be the particle. At that time, Bohr said in that conference, or after that conference, Bohr said that Einstein, do not tell God what to do. So that was Einstein was very distracted, and that conference 1927 was over with another terrible debate between Bohr and Einstein, because Einstein always opposed with the uncertainty principle given by Heisenberg. 2 days, I think, conference were completed in 2 days. At that time, only the debate between Bohr and Einstein was there. Einstein always tried to put a theoretical model to the Bohr. Bohr throughout the night discusses with the other persons what is the solution of that, what is solution of that, because Einstein always tried to fail how the Werner-Heisenberg uncertainty principle is failed. It is not true. And Bohr always take the special theory of relativity or some other and proved that Einstein is wrong and Heisenberg is right. And in that situation, they left the Brussels. After that, in 1933, Einstein went to USA because Nazi regime came into action in the Germany, and Einstein was a Jew, so he left the America in 1933, and in 1935 he brought a paper, that is EPR, Einstein, Podolsky, and Rosen, a paper to oppose the quantum mechanics. He was saying that quantum mechanics is not complete. Something there is missing, and that must be missing variables we have to found, because it is not related to the actual universe. That is why it is opposing. And after that, he always was opposing. What was in the Brussels or Copenhagen interpretation conference or Brussels or actual outcome of the quantum mechanics? Quantum mechanics says that suppose there are 2 electrons, they are in spin motion, and they 2 electrons using the quantum mechanics, they are entangled, means of that part of one atom. They will be always expressed their behavior by using a single wave function. And if one electron is at Earth, and if we take another electron is on the moon, and they are always entangled, and they are in superposition state, means if we don't observe, means the spin will be either up or either down. In superposition state, this will be either up and up, either down. But when we look, means this is a cat, because Schrödinger introduced the cat in quantum mechanics. It is a very interesting chapter in the quantum mechanics of the cat. When a cat looks at one electron, at that time the electron will either get up or either get down position. At the same time, they are in entanglement. the another electron which at the moon will take, if it is take up at that time, at the electron at the moon, it will take down spin, but both spin will be 0. So this was the connection between those two. So Einstein rejected it. He said that it is a spooky action at a distance. So no signal is traveling from this earth to the moon. How if it determines one particular state? How he knows it? Second electron, how knows he is down or up? And he has to take opposite position. And this is the base of the quantum entanglement. People don't find any spin motion of electron. They are considering as a photon. And we know that in the light wave, there is only electromagnetic wave, not electromagnetic wave, only electric field. There is no photon. Means they are measuring the polarization of the light. Photon means only they are measuring the polarization of the electric field. Nothing will be obtained. And this is the point that is always in the question. What will happen? There is one another turning point came in the history of the quantum science. Up to 1935, there was no any more debate. Up to the 1964, and in 1964, what happened is John Bell was, I think, a physicist, was from American. He brought one theorem which is called inequality theorem, and to test whether the Bohr was right or Einstein was right, because Einstein died in 1955. I think Bohr was also died before 1964. I don't know exactly the date. And he came to brought to test which is there any quantum entanglement or not. And for that he used a photon. He derived a particular theorem. And first time John Clauser and Stuart Freedom, they tested it in 1972. But actually they used a laser beam, means polarization of the laser, and they considered that laser beam has photons. And they did experiment. And they consider that, they declared their result, Bohr is true. After that, much experiment were again trying. If there is entanglement between photons, then can we build any system that is actually one photon is here, another photon is as a moon or maybe a Saturn, maybe anywhere. And if you manipulate one photon, that will directly manipulate the second photon there, and there is no any connection between that two. That is whatever we signal given to one photon, that will directly give a signal to the second photon. A communication system can be built on that of the photon entanglement. This was thinking, and for that quantum computers has to be developed. And for there is an entanglement between photons. They proved from this, that is not only 2022, but in their whole life. And their work from the whole life, Nobel Prize was given 2022 to these three. That is John Clauser, who did first experiment in 1972, and the Latur also. And this is the quantum computer. That is the image given by Google first, proposed here. Now, what happened with the quantum mechanism? Though we see that actually electrons are balanced at particular distance, there is quantum nature, not like the photon, not like any particle wave behavior and so on. So without that, we went from 19 up to this 2026 in a other way, means not in a proper way. That's why we came to this position. Now, what happened in the history? Actually, Boltzmann, who was first saying that there must be atom. Boltzmann, we know that Boltzmann law was worked with Max Planck, and his statistical distribution law obtained for that gas particle from one volume to another volume and go, what is the change in entropy he was calculating. And that's why he considering that there must be molecules and atoms. At that time, the people, that is friends with him, they are teasing Boltzmann that, have you seen any atom? Have you seen any atom? What happened? Unfortunately, Boltzmann went, what we say, in seriously depression. Boltzmann went seriously depression. He committed to suicide in 1906, friends. Because of that hammering up, have you seen the atom? Have you seen the atom? Have you seen the molecules by their friends? He committed. We know that what is its contribution, his contribution. He committed his suicide in 1906. And later what happened in 1909 to 1911, Rutherford discovered the atom. Means prior to only 6 years he committed, because people were saying. What happened to the Max Planck? Max Planck proposed only the molecular oscillator can give energy in the form of bundles of. But he always said, Latur also always said, that hypothesis of quantum energy was only formal to obtain the theoretical equation. He was not in the way to make any revolution in the physics. He was a very straightforward man. But what Einstein took benefits of that, and he brought the photon theory, that is particle nature of the light. He brought, and what happened in the last year? He was not believing on his own theory. He was not able to believe on the quantum theory whole, and he also went to the frustration. But he could not come forward and say to the world loudly that something is very happening, something is very, very mistake done. What happened in the Ehrenfest? We know that expectation value in the quantum mechanism given by Ehrenfest. He was also not tuned with quantum mechanism. He was always thinking about, he was away, he's going thrown away from the quantum mechanism people. That is, these are the people that maybe the Bohr, that is the Planck, and the Einstein, and the Heisenberg, Max Born, Schrödinger, and so on. So because of that, he went again in frustration. And in 1933, he first shoot his children and then shoot himself, and he died. That is, he committed to suicide. What happened to Philip Leonard? Actually, Philip Leonard was not accepting, that is the Einstein. He got Nobel Prize in 1905 for the cathode ray generation, means the photoelectric effect. But at the Nobel lecture, he has not taken the name of the Einstein, because at that time Einstein has given the theory of photoelectric effect, that is light quantum theory. And lastly, Einstein also frustrated from the quantum mechanism. So I think, friends, this is the too much happened in the history, and we are only what is current what is current going. We are only attracted there. This is not the way. We have to go in the history. We have to see how in the little sources they have done good experiments, where the clues they were ignored, and what the clue were they considered at that time. What will be the current situation and position of the physics? We have to think and come, because coming generation will think what in last 100 and 120 or 200 years, what we have done. If they found we are totally wrong, what will happen? They think that if one person become wrong, no doubt. But all people become wrong. Not only for 1 and 2 years, but 102 years, all the society, all the world become went in a wrong way. That's it will be very terrific for the coming generation. Because of that, whether we are going in the wrong direction, we have to think. That's my aim was to give you just as a history, as a summary type to all of you. And the topic of the conference actually chosen by Dogger sir. It is very good. I like this topic. I love this topic. Whatever I may not be able in my life to prove all such wrong or something wrong has happened. But what will happen? I will try to put what are the evidences that I thought to put in the world in the form of papers. Next generation, when will they found that, at least they found that when advanced technology comes, and they found that actually they could take picture of photo of atom and molecules, and they found where the electrons are situated. At that time, our spin atomic model will be the best model for them to understand how the electrons are situated in atoms and molecules and why. At that time, they will have a target, that is to build the theoretically. That's all of I want to express. So very good opportunity given me by the Basweshwar College and all the inaugural team. Sir.
Thank you, sir. Thank you. It's a very nice, very interesting topic, and it's the world will think about the new quantum mechanics, and you have taken many efforts, and effortlessly you have talked for a long time. So I will give the charge to a vote of thanks. Deval sir.
Okay, thank you, sir. So actually, without quantum mechanics, there will be no internet, no video games, no social media, and also know medical science. Thank you so much, sir. It is a very informative session. Now we are going to last session of the webinar. It is a vote of thanks. Before going to the vote of thanks, I will say that all the participants, feedback link will be shared in chat box of Google Meet and YouTube link, and also WhatsApp group. I call Dr. Karan Singh More sir for the vote of thanks. More sir.
Good afternoon to all. As we come to the conclusion of this international webinar, it is my pleasure to person of vote of thanks of behalf of the organization committee, Mahatma Basweshwar College, Latur, and Indian Association of Physics Teachers, IAPT. I would like to extend of heartfelt gratitude to the president of our institution, Honorable Shri Adinath Sangve sir, Vice President Honorable Shri Madhavrao Patil sir, Secretary Honorable Shri Madhavrao Patil Takekar sir, Joint Secretary Honorable Shri Sunil Mitkari sir, and other directors of Education Society. I would like to extend heartfelt gratitude to Dr. K.M. Jadhav sir, Emeritus Professor in Physics and All India Secretary of IAPT for his inaugural speech, and Dr. Dilip Sapte sir, President of IAPT Marathwada region, for his presence and the cooperation. Thank you to today's webinar keynote speakers, Dr. G.H. Jadhav sir, for his thoughts. Also, thank you to today's international webinar eminent speakers, Zaklina, Lubej, Mahle, Constructors University, Maribor, Slovenia, and Antonija, Barisic, Velika, Gorica, Zagreb, Croatia, for their insightful ideas and the given themes. That I would like to extend a heartfelt gratitude to the principal, Professor Dr. A.T. Shivaji sir, for giving the permission to organize the international webinar and his work cooperation. Then I would like to thank Dr. Reddy sir, Chief Coordinator of our college, for his encouragements and cooperation. I would like to thank to the thanks to the conveners, Dr. S.M. Dongarge sir, co-conveners Dr. A.H. Hedav sir, and Assistant Professor R.S. Devde sir, for their constant efforts to make his webinar successful. I would like to express the sincere appreciations to all national and international participants. Also, I would like to thank National Advisory Committee, International Advisory Committee, and local advisory committee for their efforts to cooperation. Last but not least, special thanks to Dr. M.M. Bedkar sir for their technical support, and also thanks to all technicals and non-technicals team, dedicated members for their efforts and cooperation. Lastly, I would like extend special appreciation to all
teaching and non-teaching staff for their efforts to make this webinar successful. With the permission of today's webinar presidents, the webinar is end. Thank you very much.
Okay, thank you, sir. Feedback link already sent by chat box.
हॅलो. हा सर.
आपलं 13-14चा IAPT ते सांगा ना. जय महाराष्ट्र.
सर एकच मिनिटात ते सांगतो सर. One announcement is there on 7th and 8th.
No, 13-14. 13-14.
एक मिनिट बघून सांगतो. सर एकच मिनिट. So one announcement is there. Please wait for some time. There is a national conference on revolutionizing physics education, integrating quantum technologies and artificial intelligence. So please register. It is on 13th and 14th, and it is organized by IAPT and MGM University at Chatrapati Sambhajinagar. And the convener of this conference is Dr. Professor K.M. Jadhav and Dr. Kranti Jhadke. So all the participants who are listening on Google Meet and as well as on the Facebook, YouTube channel. So kindly take care about this and be registered and be present in the conference and be participate in the similar conference where the direct discussions and conclusions will be there in the conference. And if you register it, it will be very beneficial to your new technologies like quantum technologies and artificial intelligence. Thank you.
Invitation तीन तास लागतील आपल्याला यायला जायला नाही म्हणलं. 6 वाजता लागलं ना आता.
So all the participants, they have to fill up the feedback form, and then the certificate will be generated on the website itself or on the group itself, and that you can take its print from your own place, and that will help you to present it because it is a proper organized webinar, and you can use it as a record for BSc students. Also, it is beneficial. So kindly go for the feedback form. Thank you. आपण भरू feedback form.